Welcome to this 2-hour preview of the modern GraphQL Bootcamp. I'm Andrew Mead, and the goal of this video is to give you a feel for the class before you enroll. What we have here is literally the first 2 hours of the course exactly as it exists on Udemy. In the description down below, you'll find a link to the course landing page. There you can check out the course curriculum and explore all of the fun and interesting projects we'll end up building along the way. All right, let's go ahead and jump right in to the course preview. Welcome to the class. Thanks so much for joining in. I'm Andrew, and together we're going to explore what GraphQL is, why it's useful, and how we can use it to build better applications. Now, we'll get into all of that shortly. I just want to take a moment in this one to talk about a couple of important things. We're going to talk about how we'll be spending our time together, so I'll break down what we're going to cover in each part of the course, and I'm also going to offer up a few tips and suggestions for getting the most out of the class. The course itself is broken up into two major parts. In part one, we're going to focus on learning the fundamentals of GraphQL and figuring out how we can integrate it into Node.js. So here we'll be focusing on the core building blocks, those built-in features, learning how we can build our own GraphQL applications from scratch. Now that's part one, and we'll be starting that in just a couple of videos. In part two, later in the class, we'll transition into integrating what we learn about GraphQL in part one with all of those real features we'd expect from applications. Things like authentication, database storage, production deployments, automatic test suites, and more. By the end, you'll have a real application. So part one, those building blocks. Part two, integrating the building blocks to create a real-world app. All right, let's go ahead and talk about a couple of tips and tricks for getting the most out of the class. This course was designed to be completely interactive, so as you move through the videos, I'm going to be typing code on the screen. It's important that you have your text editor open and that you're typing that code out as well. As we progress through the videos, we're going to end up building on our existing application, and you want to make sure you have all of the same features that I have. Now, this is sort of a monkey see, monkey do situation. That's great for when you're first exposed to a topic, but it's not so great for retaining it or for figuring out how to use it to solve problems on your own. That's why throughout the class, I have about 85 separate challenges. These are little points in the video where I'm going to ask you to pause the video, solve a problem based off of what you learned, then you can come back and watch me work through the solution. It is essential that you follow through with both of these. So if I write code, you should be writing code, and when there's time for a challenge break, you should actually take some time to try to solve the problem on your own. That's going to make sure that when you're done the class, you can actually use what you've learned here to solve problems and build applications, which is my goal for you. All right, let's take a quick moment to talk about getting help if you need it. The last thing I want to talk about is how to get help if you get stuck. So as you're moving through the course, maybe your project fails. In the video, you can see my project working, but when you run the project on your machine, you get a cryptic error message. Or maybe you just need clarification on why we're using one technique and not something else. Regardless of what your question is, you can always ask a brand new question in the course Q&A to get help. When you do, be sure to include as many details as possible, as those go a long way towards us being able to help you faster. Things like screenshots, code samples, and error messages are going to allow us to track down and fix the issue quickly. Now, there are two other ways you can get help even faster. One is to browse the Q&A for similar questions. So we get dozens of questions every single day, and they all have answers. There might be a question similar to yours, so you can get help in a matter of seconds as opposed to having to wait a little bit for one of us to respond. Last up, if you're running into a problem and you suspect it's code related, I do include the lecture code as the zip download for each and every lecture here on Udemy. So you can always download the code I wrote in the video. You can then compare my code to yours and likely find the problem. If not, as always, feel free to ask a question in the course Q&A. All right, that is it for this little welcome video. Let's go ahead and jump right in to the next one. This course contains a lot of new information, so to make that information easier to digest and remember, I've included a PDF companion with the class. This PDF guide can be downloaded as part of the lecture resources for this lesson, and I recommend taking just a quick moment to download it, crack it open, and see what it's all about. The guide itself contains lecture notes as well as documentation links and code samples for everything we talk about in the class. It's a much more scanning-friendly version of the course. It's not meant to be read front to back like a book. It's meant to be your companion as you move through the class. So if you forget where I said something or exactly what we talked about, the PDF guide can get you that information quickly and easily. Alright, that's it for this one. Let's go ahead and talk about why we should ever use GraphQL. In this video, I want to take a few minutes to explore an important question, arguably the most important question we have right now, which is why GraphQL? We're about to spend a lot of time together learning this new tool, so we want to make sure it's going to be time well spent. In this video, we'll be talking about where GraphQL fits into our applications, we'll explore some of the benefits of using GraphQL, and lastly, we'll talk about why it's become such a popular tool. I want to kick things off by talking about where GraphQL fits into our application. Now, if you're like most people, your current application likely uses some form of a REST API, where you're making HTTP calls between your client and the server to send and receive data. Your application likely has at least one client. I'm going to go ahead and say that for our fictitious example, we have a few different clients. Let's say that we have a web application where users can log in to manage their data, and let's say that we also give them a mobile application, one for iOS and one for Android, that they can take with them on the go. Now our clients, these three, represent just part of our entire application stack. We also have our server and our database at a minimum, so let's represent those over here as well. Maybe we're using Node.js with the MongoDB database, maybe we're using Python with the Postgres database, or maybe we're using Java with MySQL. It doesn't matter. Any number of clients, phones, TVs, laptops, can communicate with any number of servers because the glue between the two has always been standard HTTP requests, typically represented as some sort of REST API. Our REST API might have a dozen or so different URLs, different endpoints that can be used to communicate with the server. Maybe we have one for signing up, another for logging in, and let's say we're creating a blogging application. So we have one for creating a new post, and we have one for reading all of the available posts in the database. This is a pretty typical setup. When we introduce GraphQL, not a whole lot's going to change. We're still going to be able to use any client, and we're still going to be able to use any server, although in this course, we're going to be focusing on Node.js. All we're going to do is replace our REST API with many endpoints with a GraphQL API that has just a single endpoint exposed. GraphQL stands for the Graph Query Language, and this is something that also operates over HTTP, which means that we can use any backend language we want with any database we want, and we can use any client we want. Maybe we have a web and mobile app. Maybe we also need to communicate with this GraphQL API from another server. That's perfectly fine as well. GraphQL is super flexible, and we're going to see this throughout the course. So next up, I want to quickly go over why GraphQL is something that you should consider using. First up, GraphQL is fast. And to explore this, I want to go through a typical example of what it might look like to load the data necessary for a page with a REST API and then with a GraphQL API. So let's say that we start with the REST API example. We still have some sort of client, let's just say it's a browser, and we have our server. The glue between the two is that standard REST API, where we have a dozen or so different endpoints for managing our application data. Let's go ahead and make some HTTP requests to render a page, and let's say this page is a page for reading a blog post. So we need the title of the post, and we need the post body. How do we get those? We make an HTTP request. That might look a little bit like this. We make a GET request to the following URL, /posts/123, where 123 is that post ID. The server is going to parse this URL, it's going to find the correct data, and it's going to send it back likely in the form of JSON. So the server responds saying something like, here are the post details. Now maybe we get those post details rendered to the page, and we realize we want a bit more information. I also want to show at the end of the post other posts by that author because I want to keep people on the site. I want to give them something to read when they're done what they're currently reading. If I need more data, I make another request. Right here, I can make a second HTTP request to something like get/posts. Here I'm using a query string to filter by the post author. I want to find only posts with the following author ID, 3421, just a made-up ID. Let's assume this is the author ID of the post that we fetched. The server, once again, is going to parse all of this. It's going to try to find other posts by that author, and it is going to send them back so we can correctly render some of them at the bottom of the post page. Now let's say there's just one more thing we need to get. We need the comments made for this post so we can show those at the bottom as well. Right here, we're going to make our third and final HTTP request for another resource. Here, we're still making a GET request to /posts/123, the post ID, /comments. So we're getting all comments for that post. This is a pretty standard REST API URL structure. Once again, the server goes off, it parses this, and it sends back the data. And finally, we have everything we need. We can get everything rendered to the screen, giving the user the best experience possible. Now let's see how we might fetch the exact same data to render our blog post page, but using a GraphQL API. So we still want the post details like the title and body, I still want other posts by that author, and I still want the post comments. Right here, we have a client, we have a server. This time though, GraphQL is the glue between the two. And remember, GraphQL can operate over HTTP, so in the end of the day, we're still just making HTTP requests. Let's go ahead and make our first one, getting the data needed for this page. Now, the request we're going to make is going to be a post request, and GraphQL exposes just a single endpoint. That's a very important piece to the puzzle. Now, you could have called this whatever you liked. For this example, I happen to call it GraphQL, but we'll see how to rename that throughout the course. Now, here's the catch. With our request, we're going to be sending along a GraphQL query. A GraphQL query lets the client describe exactly what data it needs from the server. The server then gets all of that data ready and it sends it back. So the client can describe exactly what it needs and it gets that data, nothing more and nothing less. This is a very powerful piece to the puzzle. Instead of the server determining what data gets sent back, it's up to the client to request all of the data it needs. So in this case, I can actually request the post details, other posts by that author, and the post comments all with a single GraphQL request. Now, the magic behind all of this is that GraphQL query, but that's actually not something we're going to talk about in this video, though it is a major topic of the course and we'll be getting to it very soon. For now, all we need to know about the GraphQL query is that it lets the client determine what data it gets back, as opposed to a traditional REST API endpoint where the server determines what data comes back from an endpoint. Now, clearly, 3 requests is more than 1 request, so GraphQL, in the end of the day, is going to be faster. It's going to allow us to get all of the data we need with 1 HTTP request. Now, raw speed alone is not enough to make a tool useful, and while that is an advantage of GraphQL, it's definitely not the biggest advantage. In my opinion, the biggest advantage is the flexibility of GraphQL. So with that last example, you could have easily argued that the REST API portion of the example was completely contrived. I intentionally chose to make it 3 requests instead of 1. Clearly 3 is bigger than 1, so obviously it's going to be a bit slower. But I made that choice to prove this point. We could absolutely cram all 3 of those endpoints into 1. So let's revisit our REST API example. Right here, we have our client, our server, REST API is the glue. We make our single HTTP request. Here I'm just using that first endpoint we had. We get the post by ID. And what do we get back? We get back everything. We get our post details, which is the title and the body. We get the comments for the post, and we get other posts by that author. This would be a perfectly fine approach. It would give the client everything it needs to render that page with just a single HTTP request. The problem with this solution is that we now have this one endpoint, which is making way more database requests than it was before. It's getting big and slow. It went from maybe making 1 database request to making at least 3 requests in order to get all of the data necessary. Now, for the desktop version of our app, that might be fine. Maybe we're going to use all of the data right away, so let's just get it. But what if we want a mobile version of our application to use the same backend? We make the HTTP request to that URL, and the problem is that the mobile application can't change the data it gets back. On mobile devices, we have a whole different set of considerations. We have less screen real estate. We have battery life to worry about. We have slow and expensive data. We want to make sure that we're not abusing the device, otherwise people are going to get a poor user experience, the app is going to feel janky, and they're likely to uninstall. This is actually the original reason GraphQL was created. Facebook had the same problem. They had a desktop version of the application, they had a mobile version of the application, and they didn't always need the same data for both. They wanted a flexible way for the individual clients to request exactly the data they were going to use. Nothing more and nothing less. So maybe on the mobile device, we don't want to load the comments until someone clicks a button at the bottom of the post like Show Comments. With this solution, it doesn't really matter because the comments have already been loaded. It would be nicer if we could fetch the comments later when necessary. So the desktop and mobile devices both have different needs. This is not an issue we're going to run into with the GraphQL API. On the desktop, we make a GraphQL query specifying we need all of that information. We need the post itself, we need the comments and other posts by the author. And on our mobile device, what do? We make an HTTP request to the same endpoint with a different GraphQL query. In this case, we say maybe we just need the post details. So we get back just the post details. So with the website version of our application, where the query asks for a lot of data, the server is going to have to do a lot of work, making those 3 or so database requests necessary to get everything. The nice thing, though, is that on the mobile version of the application, where the query asks for less data, the server does less work. In this case, making the one database request necessary to get the post title and the post body. With the REST API, we didn't have that same flexibility. We got the same response with both. With GraphQL, it is the individual client that determines what data it gets back from the server. With a REST API, it is the server that determines what data gets sent back to what endpoint. And that's a huge difference. Now, yes, in the end of the day, you could go ahead and try to customize your REST API, maybe adding on query strings to determine whether or not you want the comments and whether or not you want the other posts by that author. But at that point, you're getting dangerously close to just recreating what GraphQL already offers. That's why huge companies like Facebook and GitHub are using GraphQL in production today. It provides the speed and flexibility needed for real-world applications. So we saw that GraphQL was fast and flexible. GraphQL is also easy to use and simple to maintain. With a REST API, if the client needs different data, it typically requires us to add a new endpoint or change an existing one. Using a GraphQL API, though, the client just needs to change its query, making GraphQL APIs much simpler to maintain in my own personal opinion and experience. So that's it. At this point, we've definitely asked more questions than we have answers to. For example, we have no idea what a GraphQL query is or how we're going to set any of this up, and that is okay for the moment. We're going to dive into all of that in detail, as always, a bit later in the class. For now, the only thing you really need to take away from this video is the following. GraphQL creates fast and flexible APIs, giving clients complete control to ask for just the data they need. This results in fewer HTTP requests, flexible data querying, and in general, less code to manage. We get all of the same advantages with this increased speed and flexibility. I am super excited to dive into the rest of the course and actually put all of this into practice with a real-world, production-ready application. So let's go ahead and jump right in to the next video. Before we wrap up this section and dive into GraphQL, there are 2 things we're going to have installed on our computers. The first is Node.js, which you can find at nodejs.org. Since knowing Node is a prereq for this class, hopefully you already have it installed on your computer. If you don't have Node installed or you're using a much older version, just go ahead and grab V8 of Node or higher. You can grab the installer, run through it by clicking next a bunch of times, and then you'll be all done. The exact version of Node you use with this class does not matter. All of the GraphQL functionality that we're going to be exploring comes from specific NPM modules, which we'll be installing later. We just need a semi-modern version of Node to get the environment up and running. V8 of Node or greater is going to work perfectly fine. So V8, 9, 10, or whatever else comes out in the future. So run through that installer, make sure you have Node installed, and if you do, we can move on to the second tool, which is going to be a text editor. As always, you are more than welcome to use whatever text editor you're comfortable with. If you're interested in following along and setting up your environment just like mine, I'm going to be using Visual Studio Code. You can find that over at code.visualstudio.com. If you haven't used it before, I recommend giving it a shot. It's a fantastic editor that integrates really well with all sorts of environments, including GraphQL. Visual Studio Code is free, it's open source, and it's available for all operating systems. So if you do want to use it, go ahead and grab the installer and get it installed. We're going to wrap up this video by going over the plugins I'll be using for VSC in this class. Now, some of these plugins will have replacements in other editors, but I can't guarantee that. So here's the plugin list I'm using for Visual Studio Code. I got about half a dozen or so that really come in handy. The first one, Babel ES6/ES7, just gives us support for all of those modern features like arrow functions and async await. The next plugin, Beautify, allows us to format our code on the fly. After that, we have Docker, which is going to come in handy later in the course when we worry about deploying our applications. After that, I have Duplicate Action. This is a simple one that allows me to right-click files or folders to duplicate them inside of the file tree. After that, I have GraphQL for Visual Studio Code. I definitely recommend installing this one, as it's going to give us syntax highlighting for the GraphQL code that we're going to be writing very soon. After that, I have NPM and NPM IntelliSense, which just give me better support when working with NPM modules, something we will be doing in this class. Then I have Sublime Text Keymap. I use that because I really fell in love with these Sublime Text keyboard shortcuts. I had a really hard time switching to some of the Visual Studio Code defaults. This one, like all of these, is completely optional, but if you do like the Sublime Text keyboard shortcuts, it's a great tool. Last up, word count, just counts the words in a markdown file, nothing fancy there. So these are all the plugins I'll be using throughout the class. If you have Node installed and a text editor installed, you are ready to dive into the next section where we're actually going to start learning about GraphQL. I am super excited to get to it, so stay tuned and I will see you then. Welcome to section 2. In this section, we're really going to get started with the course. We'll start off by exploring exactly what GraphQL is, for example, what's a graph. Then we'll dive into actually using GraphQL inside of a Node.js application. By the end, you'll have a pretty good idea of what exactly GraphQL does and how it does it. I'm excited to get to it, so let's go ahead and jump right in to the first video. To kick off this section, I want to answer a very important question, which is what is a graph? It's right in the name, GraphQL, and it's something that we're going to have to learn a little bit about before we can continue on. Now, when we're talking about a graph in GraphQL, we're not talking about the kind of graphs or charts we would create in a tool like Excel to plot some points over time. When we talk about a graph in GraphQL, we're talking about a way to think about all of our application data and how that data relates to one another. And we're going to move through a quick visualization in just a second to show how this would look in a real-world application. Before we continue on, you might have noticed this is a presentation video. I avoid using presentations like this as much as possible in my courses. I use them very sparingly only when I truly believe it is the best way to get information across. And in this video, I think a presentation is the best way to explain what a graph is. Don't worry though, like all my courses, 99% of this class is me and you in the text editor writing code, but going through the process of exploring what a graph is going to give us a solid foundation for actually writing code very soon. For this visualization, let's use the example of a blogging application. So we have users that are going to sign up and log into the application. Once they're logged in, they're going to be able to create and publish posts. And once a post is published, other users are going to be able to read that post and add comments onto it. So as I described in English, there are three main things that we're going to be storing for this application. We're going to be storing users, we're going to be storing posts, and we're going to be storing comments. In GraphQL, these are known as types, and types are things that we define when creating our GraphQL APIs, something we'll be doing in just a few videos. So in this case, we have a user type, we have a post type, and we have a comment type, all things that we define. And when we define the types that make up our applications, we also define the fields associated with each type, the individual pieces of data we want to store. So in the case of a user, what do we want to track? Well, that's really up to us to figure out what makes sense. For all of our types, we're going to have a unique ID to uniquely identify that user or that post or that comment. In this case, let's say it's the string 1. And after the ID, it's really up to us to choose what we want to track. So for a user, maybe we want to track their name under a name field. We'll store that as a string, and an example would be my name, the string Andrew Mead. We could also choose to track other things like their age, and for me, that would be the number 27. Now, each type we create is going to have its own set of fields, so all users are going to have an ID, a name, and an age. All posts are going to have a completely different set of fields. For a post, we're still going to have an ID, something to uniquely identify that post, but then we're going to track things specific to the post, like the post's title, the post's body, and whether or not the post has been published. So in this case, I have added a title for my post, the body is completely empty, and this post is not published. So we're storing the Boolean value false for unpublished, as opposed to the Boolean value true, saying the post is indeed published. The last type that we're going to be working with in this example is the comment. So a comment is also going to have an ID, in this case 99, and for comments, the only thing we're going to keep track of is the comment text. And in this case, we have a very nice comment just saying, thanks for the post. So for this visualization, we've created 3 types, user, post, and comment, each with their own custom set of fields. All of this should seem familiar because it's exactly how we would represent our data with any standard database out there. If I was working with an SQL database, I would have a users table, a posts table, and a comments table where all of the individual fields were individual columns on those tables. If I was working with a NoSQL database like MongoDB, I would likely have a users collection, a posts collection, and a comments collection where all of these fields were fields on the individual documents created. Remember that GraphQL doesn't care what backend you're using, so in the end of the day, it might be an SQL database or it might be a NoSQL database. Either way is perfectly fine. Now, aside from each of our types having their own discrete set of values, we also have relationships between our types. So for example, if a user creates a post, that post is associated with the user. So we would have a relationship like the following, where a user has many posts via the posts property. Now to save space here, this user just has a single post, but we could easily imagine they have 0 posts or they have 42 different posts. Now, if a user has many posts, that means a post also belongs to a user. So each post is associated with a user via the author property on that post. Now there's relationships between our other types as well. For example, the comment to post relationship. A post can have many comments, and maybe we access those via the comments property, and a comment is associated with a post via something like the post property. Last up, comment to user. A user can have many comments they've written on all sorts of posts, while a comment always belongs to an individual user, and we might have that association via the comment author property. So in the end of the day, our graph could look a little bit like this, where we have types, user, post, and comment. They have discrete fields, and they also have associations between various types. In the end of the day, this is how we're going to be thinking about and representing our data in GraphQL. That's where we're going to stop for this one. Now that we know the basics of what a graph looks like in GraphQL, we're actually ready to move on to the next video where we're actually going to put our hands on the keyboard and write some GraphQL code. We're going to figure out how we can query from a real GraphQL API. I'm excited to get to that, so let's go ahead and jump right in to the next one. You've learned that GraphQL is fast and flexible because it's the client that sends a query to the server asking for the exact data it needs. In this video, you're going to see that in action by creating and running your very first GraphQL query. So we're going to be making requests to a real-world GraphQL API. Now, as with a REST API, we're going to have a client and a server. In the case of this course, the client is going to be a web app, and the server is going to be a Node.js GraphQL server. We're not going to worry about either of those just yet. That would be getting a little bit ahead of ourselves. In this video, we're going to focus on making a GraphQL request to a server I've put together for us, allowing us to explore this syntax without needing to write a ton of code. Though don't worry, we will start setting up our very own GraphQL API in just a couple of videos. For the moment though, let's go ahead and mess around with GraphQL Queries by heading over to a URL. This is GraphQL-demo.mead.io. And when you head over there, you should see exactly what I have here. The tool you're seeing here is called GraphQL Playground, and it's a little request response tool for GraphQL. So we can see what would happen if we submitted a specific query to a specific GraphQL API. It's a tool we can actually install as a standalone program on our machines, and we will be doing that a little bit later. By the end of the course, you're going to be very familiar with how this tool works. If you've ever worked with a REST API, you've probably used some sort of HTTP GUI in the past, maybe something like Postman or Insomnia. In the end of the day, the GraphQL Playground tool is the exact same thing. On the left-hand side, we're going to type out our queries, specifying the data the client wants to request. We click the play button, it's going to go off and actually make a request to the API I've put together, and on the right-hand side, we're going to get a response. Now remember, with GraphQL, we just have a single endpoint, so there's no need to make any changes to the URL. You should already have exactly what I have here, and we're not going to make any changes to that. The only thing we're going to have to change is the code that goes in this box on the left-hand side. This is where we type out the GraphQL operations we want to perform on our server. Let's go ahead and start by removing everything inside of here, which is just this single comment on line 1, and it would be perfectly fine to leave that comment in place. I'm just removing it for simplicity's sake. Now, we're going to go ahead and specify our very first GraphQL operation. There are 3 major operations we can perform on any GraphQL API. One of them is the query, and that's what we'll be starting with. The query allows us to fetch data. So right here, we start off with our operation type. For a query, it is query in all lowercase. Then we're going to type a space. We're going to open and close a set of curly braces and hit enter inside. Later in the course, we'll be learning all about the other 2 types of operations we can perform. One being the mutation, which allows us to change data. The other being the subscription, which allows us to watch data for changes, which is great for real-time applications. Now we can see we're getting a little error with this query, and that's because technically we have an invalid query. It's not asking for any data, which means that it shouldn't even be sent off since no data is going to come back. What we have to do right here inside of these curly braces is specify what fields we want from the GraphQL API. Then we'll have a valid GraphQL query that actually fetches some data. On this demo GraphQL API, I've set up a few different fields we can actually query from the server. One of them is called hello, and to query that field, all we do is type the field name right here. Now what we have here on the left-hand side is a completely valid query. It might look a little bit like JSON or some sort of weird JavaScript object, but it's not. It's the GraphQL language, and we'll be exploring it in more detail and looking at all of the awesome stuff it has to offer as we progress through the course. For now though, we have a perfectly valid operation. We're performing a query on our server. We're requesting a single field hello. Let's go ahead and run our very first GraphQL query by hitting that play button. And what do we get on the right-hand side? We get back some JSON data. We get back an object with a single property data, and on there, we have all of the data we requested. In this case, we requested a single field hello, which shows up right here, and then we have the actual data that came back from the server. In this case, it was the string hello world. So this is fantastic, our very first GraphQL query with just 3 lines of code. Now let's make this a bit more interesting by requesting more than just a single field from the server. Remember, we can request as much or as little data as we need with a GraphQL query, but typically it'll be more than just 1 field. So how do we do that? Well, right here, we're just going to add a new line inside of the curly braces for our query operation, and we're going to specify the field we want access to. I have set up another field for us. It is called course instructor. Course instructor is going to return a string, much like hello, and in this case, it is going to contain my name, the course instructor. Now you'll notice there is no extra punctuation inside of the curly braces. We just have the field names on separate lines. So I'm not doing anything like adding a comma right here like we would see with JSON or a JavaScript object. It is just field 1, a new line, field 2. Let's go ahead and actually run this query by clicking that play button. And what do we get back? We get back our data object, this time with the 2 properties we've requested. We have our field hello with the string value hello world, and we have the field course instructor, the new one, with the string value Andrew Mead. Now, so far, both of the requests we've made, this one and the last one, have worked. We've gotten a valid data response, and that's because both of the fields we've requested are real fields that the server was set up to know about. What happens though if we type in some random field name that the server does not understand, for example, course price, something I have not set up for this API? We can see that right away we're actually getting an error, and if we hover over that, we get the following message. Cannot query field course price on type query. Did you mean course or course instructor? So we're getting some very useful feedback. It's saying that the field we're trying to access doesn't exist, and it's suggesting some other fields that actually do exist. We'll talk about exactly what the type query with an uppercase Q means a bit later when we actually set things up. For now, the important thing to note is that we're getting very useful feedback on our fields before we actually ever send the request off. How's all of this possible? How, for example, am I able to type in H and have it know that there is a hello field I can actually request? That is because, by nature, all GraphQL APIs are self-documenting. This is not a feature we get with REST APIs. With a REST API, someone needs to manually write and update documentation. And in my own personal experience working at companies, the documentation either 1, doesn't exist, or 2, is severely outdated and basically useless. So what do you end up doing? You end up just making a dummy request to the endpoint, dumping all of the data to the console just to figure out exactly where the data you need lives. What fields contain the data I need to render this page? With GraphQL, we do not run into the same problem because your request dictates your response. We're specifying the exact things we want access to, so we know what the response is going to look like. We don't have to play that guessing game anymore. All of this is possible because your GraphQL API exposes an application schema, which describes all of the operations that could be performed. In the case of the query operation, it describes all of the fields you're allowed to select. That's why we're able to see that a field like test is invalid before we ever even send the request off. Now, using this tool, GraphQL Playground, we can view the schema via this schema tab on the right-hand side. Now, there are a few things in here we're not going to talk about just yet, but let's go ahead and crack it open. I don't want to leave it as a mystery. The first 4 fields are fields we're going to ignore. They're a bit more complex, and we'll talk about them in the next video. That's users, posts, post, and me. What I want to focus on are the last 3, hello, course, and course instructor. Now we can see that for hello, we have the field we can request, and we also have the type that we're going to end up getting back. In this case, it's a string, which we saw. It's also true for course instructor. We get a string back. The exclamation mark afterwards just means we're always going to get that back, as opposed to being able to get null back. So we're always going to get a string response, which is what we've seen so far. Now we've already requested hello and course instructor and seeing those values. What I want you to do as your challenge for this video is to change the query to also make a request for course. Now this alone might seem like a pretty easy thing to do, and that's because I want to take this moment to introduce the challenge format. Like with all of my courses, the goal in this course is to get you writing code and solving problems on your own. That's the only way to actually learn how to use a tool in the real world. So sure, it is important that you follow along with the code I write in the video. You should have this written out already, but it's also important that you get a chance to solve problems on your own, and that's where the challenges come in. With a challenge, I set up a problem I want you to solve using what you just learned. I then give you a moment to pause the video, and you go off and try to solve that problem. Then you click play, come back, and we work through the solution together. With these challenges, I never ask you to do something that you don't already know how to do based off of what was covered in the course. I'm also not asking for perfection. There are challenges you just won't be able to solve the first time around, and that's okay. It's all about improving your problem-solving skills and taking your understanding to the next level. It's important that you follow along with the code in the videos and actually take the challenges seriously. This is where you're going to build up that pattern recognition, muscle memory, problem-solving skills, and debugging ability, all of which are critical if you want to actually use GraphQL after you're done the course. If you don't follow along with the code in the lessons and you skip the challenges, you might as well just close down Udemy right now because you're missing out on most of what this course has to offer. All right, with all of that said, let's go ahead and move on to our first challenge. As I mentioned, this one is going to be very simple because it's all about understanding the challenge format. As we move through the course and actually learn more about GraphQL, I'll be asking you to do more, write more code, and solve more complex problems. For now, your only goal is to change that query to also ask for the course. Then go ahead and run it and actually view the response on the right-hand side. Take a moment to pause the video, knock that out, test your work, and when you're done, click play. All right, not too bad. So hopefully you took a moment to pause the video and actually add the course field onto the query. Let's go ahead and do just that. I could add it at the end, I could add it in the middle, I could add it wherever I want. I'm gonna go ahead and toss it in the middle, though anywhere would have worked. So right here, we have hello, we have course, and we have course instructor. I'm requesting 3 fields. I would expect to get 3 fields back, all being strings. I'm going to go ahead and click that play button, and what do I get? I get GraphQL sitting right here, which is fantastic. If you're also seeing GraphQL as the value for course, then you are all done this challenge, and we are all done this video. We learned quite a bit in this one, so let's take a quick moment to recap. The first thing we learned is that there are 3 main operations we can perform on a GraphQL API, one of them being the query. The query is how we ask for data, and in this case, we are specifying our query asking for 3 fields: hello, course, and course instructor. We saw that the request structure dictates the response. We asked for 3 fields with these names, we got back 3 fields with these names. All of this is possible because GraphQL exposes the schema, allowing you to see exactly what data you have access to when making queries to an API. This is a very useful feature, making GraphQL self-documenting, making it a whole lot easier to actually use this tool. All right, in this video, we saw some basic queries, just requesting a couple of fields here and there. In the next video, we're going to dive deeper into some more real-world queries and actually explore those other 4 things that we saw over inside of the schema. I'm really excited to get to that and continue on with the course, so let's go ahead and jump right in to the next one. In this video, we're going to wrap up our basic exploration of queries with the GraphQL playground. In the next video, we're actually going to move on and start writing some code inside of our text editor. For the moment though, what I want to do is explore how we can query more real-world data. It's nice to be able to query some strings and actually see some data come back, but with real applications, we have complex objects and we have arrays of objects. If we stick with the blogging example, we might have an array of posts we want to show to the screen. So we have an array of posts where each item in that array, each post, is an object with a standard set of properties. A post has an ID, a title, a body, and a published value. This is exactly what we saw a couple of videos ago when we explored how we can visualize our data as a graph. Before we try to query for an array of objects, let's go ahead and just start with a simple object. If we head over to the schema, we can explore exactly what we're going to end up querying, and that is me. Now with hello, course, and course instructor, we got strings back, and that was easy to make sense of. Right here, we get string values back. But we can see that with me, for the first time, we're getting back something different. In this case, it's a user. Now, a user is a custom data type I created for this application. So for a blogging application, we're going to have things like users, posts, and comments. If I was creating something like e-commerce software, I might have users, products, reviews, and orders. In the end of the day, a custom data type like user is nothing more than an object with a standard set of fields. If we actually click on me, we're going to see the exact fields available on a user that we can query. So we can decide which of these we need, and we can structure our query to actually get them. We don't need to worry about the type definition for the moment. We'll actually build out our own custom types in the next several videos. The only thing we're concerned about is that when we get a user back, we're essentially getting an object back with 5 properties which we can choose to select in our query. Let's go ahead and mess around with an example query. Right here, after our current 3 fields, I'm going to try to query for me. And you'll notice that when I do this, we're actually getting an error. This is an invalid query. And if we hover over the error, we have the following message. Field me of type user must have a selection of subfields. And it's asking us if we meant to put curly braces after me. When we're querying on an object, we have to specify which fields from that object we want. We can't ask for everything because that defeats the purpose of GraphQL, which is to have the client request everything it needs, nothing more and nothing less. So let's say I do want some stuff from me. Maybe I want all 5 of these, in which case I would list all 5. Let's say we just want 2, the ID and the name. How do we get that done? Well, we start by adding curly braces after me, just like this. Then we list out the fields we want to select off of me. So me returns a user. Users have these fields. Let's go ahead and grab those 2. First up, ID. I simply list it like I would up here. Then if I want another field off of me, I hit create a new line and I specify that field too. Right here, I will grab name. Now we can collapse our schema tab for the moment. I'm going to click that play button and what do we get? We get a brand new property on data, me, which matches up with this. And you'll notice that instead of getting something back like a string, we're actually getting back an object. So when we query for a custom type like user, we're going to get back an object with all of the fields we asked for. In this case, we asked for ID and name, and we're getting back ID and name. And you'll notice that once again, the structure over here matches the structure over here. So hello, course instructor, and me are top level like they are here. ID and name are nested under me like they are in both examples. So we've seen a basic example of how we can query on objects. We can now add on that third field, email. I could send off a new operation and I get back the same structure. The only addition is the email property on that me object. Now that we've queried some data off of one of our types, which is essentially an object, let's go ahead and learn how we can query some data off of an array of one of our types, or an array of objects, which in the end of the day is where most of our real-world application data is going to end up living. Now for this example API, I've given us 2 options for this. The first is users, which returns an array of all of the users who currently have signed up for the application. And the second is posts, which returns an array of all of the published posts. Now, this is going to allow us to figure out how we can actually query that data. Before we use either, though, I want to talk about the syntax we're seeing right here. For hello, we learned that hello was the field we can query. Then we had a colon space followed by the type we expect to get back. In this case, the schema is saying for hello, you're going to get a string. And because of the exclamation mark, it's saying you're always going to get a string. If the exclamation mark didn't exist, we might get null back. So if there was no exclamation mark, we could either get a string like hello world or null, both would be valid. With the exclamation mark, we have to get a string back. Now let's look at a more complex type definition like the one for users. First up, we have the opening and closing square bracket. This is how we define that the return value is an array. So here we have a string, here we have a user, here we have an array. And the exclamation mark at the very end says we're always going to get an array back as opposed to being able to get null back. Now the array might be empty, but if we do have items in the array, we're saying they're always going to be of the type user, never something like null. So user exclamation mark says the array items, if they exist, will be of type user. The exclamation mark lets us know they will always be of type user and never null. So we would never get an array where the only item was null. Now this is a very standard type definition for the array of objects. We're going to learn more about it and we're going to continue to use it throughout the course. For now, let's go ahead and see what it takes to actually query for some of this data. Now we could continue to add on to this query right here, but with the GraphQL Playground tool, we can actually create a couple of tabs to have a couple of queries running side by side. So what I'm going to do is create a brand new one, allowing us to keep things nice and simple and focused on what we're trying to learn. So right here, we are still going to create an operation of the type query, and we're still going to select some fields. In this case, it is users. Now, once again, this alone is not enough. This is not going to return an array of all of the users with all of their fields. And if we hover over the error, we're getting something very similar to what we got when we had just me with no fields selected. what we need to do is specify what fields we want for each user. So right here, we open and close a set of curly braces, and this should look familiar. It's exactly what we ended up doing with me. So if this was me, we could add the fields we want off of the user. If it was users, we can add the fields we want off of every user. So let's go ahead and select a single field off of all of those users. I'm going to go ahead and grab name. So what we're doing here is we're grabbing every single user who signed up for the application, and we're getting their name. If we go ahead and run the query, we can see exactly what we get back. What do we have? We have a single property on data called users, which we should expect since we are selecting a single thing in our query. Now in there, we're not getting an object back like we got for me. Instead, we're getting back an array because users returns an array. For each object, for each user, we're getting back the field we asked for. In this case, we have 3 objects. We're getting the name for each. We have Andrew, we have Sarah, and we have Michael. We could select other things if we wanted to, like the email. I could rerun the query, and now we're getting Andrew with his email, Sarah with her email, and Michael with his email. So we're able to select as many or as few things as we need for each user in that array. Later on in the course, we'll also learn about filtering and sorting, so we could exclude certain people or sort them alphabetically, doing whatever we might need to. For now, though, just being able to fetch the data is a great step in the right direction. Now I'd like to move on to challenge time. We're going to crack open the schema, and it is going to be your job to fetch some data using posts. Now, so far, we've ignored posts and comments on user. This is relational data, so it links to the posts for that user or the comments that user has made, and we're going to continue to ignore that for the moment. We're just going to focus on the fields that actually resolve to a value, as opposed to fields that link to another custom type. The same thing is true with posts. Each post has an ID, a title, body, published, author, and comments. For now, we're going to completely ignore author and comments. Author links to the author for the post, and comments links to all of the comments for the post, and we'll be diving into relational data in detail very soon. But for the moment, we're just going to worry about these first 4 fields. Your challenge for this video is to create a brand new query, so crack open a new tab and set up our query operation. You're going to query for posts, and for each post, I'd like you to get the ID and the title. So instead of having an array of users with name and email, we would have an array of posts with ID and title. Take as much time as you need to actually get this one done. It might take 30 seconds, it might take 5 minutes or 20. Either way works. Feel free to refer to the schema and refer to any code we've written before or any previous videos to solve this challenge or any other challenge for that matter. When you have the query in place, make sure to actually run it and see if you can't get the right data coming back. All right, that is it for the setup. Take a moment to pause the video, try to fetch the ID and title for each post. When you're done, come back and click play. How'd that one go? Let's go ahead and kick things off by creating a new tab for our brand new query. Now we have to specify our operation type. The only operation we know about so far is the query, so we'll provide that, along with our curly braces, so we can select the individual fields we want. Now for this challenge, I said you just needed to grab the posts, so that's the only root field we're going to select. Now we can't just select posts because what we get back is an array of objects. So we have to specify what we want off of each of those objects. What do we want off of each post? Each post has a few different types we can pick from. We just need ID and title. So right here, we'll set up our curly braces. I will specify that I'd like the ID and I'd like the title, and there we go. That is all we had to do for our query. I can click that play button. It's going to pass the query off to the server. The response comes back, and what do we get? We get an array of posts as the only property in data. Now for each array item, each object, we correctly get the ID for that post, and we get the title for the post. So the first post, GraphQL 101, the second post, GraphQL 201, and the final post, programming music. That was all you had to do for the challenge. Now we know how to query on objects and on arrays of objects. And that's going to wrap up this little introduction to GraphQL queries using the GraphQL playground. We will come back to this demo a bit later in the course as we start to explore relational data. we'll figure out how we can use other properties like author and comments. But for the moment, what I'd like to do is take things into the text editor and start setting up our own GraphQL server. I am super excited to get to that. So let's go ahead and jump right into the next video and see what it takes to use GraphQL inside of Node.js. In this video, you're going to move away from using GraphQL Playground with the demo API, and you're going to move towards Visual Studio Code and actually writing code to create your very own GraphQL projects. In this video in particular, we're going to be setting up our little boilerplate project with a couple of nice-to-have tools for local development, especially when we're working with GraphQL and Node.js. So I'm going to crack open my editor. For the rest of the course, I'll be leaving the browser here on the left-hand side, and on the right-hand side, I will have Visual Studio Code, so we can quickly switch between the two. Let's go ahead and kick things off by creating a new directory for all of the code we're going to have in this course. I'm going to use Command O, or the command here for your operating system, to open the folder. On the desktop, I'm just going to create a new directory. You can call it whatever you want. I'm going to call mine GraphQL Course. This will contain all of the files and folders and projects we end up creating throughout the class. Let's create that directory. We're going to crack it open. And now we're going to focus on actually creating the folder for this first project. We can call that one something like GraphQL-Basics. Perfect. So we have the GraphQL course directory for all of the code in the course, and I have the GraphQL Basics directory for the specific stuff we're going to explore for this first project. Since we will be writing some code in this lesson, I wanted to remind you that there is a lecture zip available for every single lesson in the class where we actually write some code. That zip contains all of the code up until that point in the course. So if you lose your project or your project's not working, you can always download the lecture zip to compare my code to yours and figure out where you went wrong. So don't forget lecture zip for every lecture where we actually write some code. To kick things off, what I want to do is install and configure a tool called Babel in our project. Babel is a tool that's going to allow us to use the most advanced cutting-edge JavaScript features today. In particular, we're going to be able to use the ES6 Import Export syntax. Let's go ahead and kick things off by pulling up the website for Babel. That is Babel, Babel, js.io. If you come from a more front-end development background, you might have actually heard of or even used Babel before, particularly if you've worked with React. If you come from strictly a Node.js background, it's likely you've never heard of or even used Babel before, but that's okay. Setting up Babel is actually really easy. We're going to be installing 2 NPM modules and adding about 5 lines of configuration code to our project. Then we'll have Babel all set up and we'll be able to forget about it for the rest of the class. In the end of the day, Babel is a JavaScript compiler. So we write some code, we send it through Babel, and Babel spits out other code. This allows us to take advantage of cutting-edge features in our code, but still have code, the output from Babel, which runs in a wide range of environments. So if I'm writing an application, I might want to take advantage of the great features offered up by the arrow function. But if I want my code to run in an older browser like IE10, I'm going to need a way to actually convert that arrow function to something that IE10 understands, because IE10 does not and never will support the arrow function. What's the solution? The solution is to just pass that code through Babel. Now, as I mentioned, in our particular use case, we're going to be using Babel so we can access the ES6 Import-Export syntax from Node. You can learn more about Babel by actually seeing it in action and heading over to the Try It Out page. On this page, we type some code on the left-hand side, the output ends up on the right-hand side. Let's go ahead and give this a try. I'm going to create a simple statement, const my function, setting it equal to a brand new arrow function that takes no arguments and has no function body. So on the left-hand side, we had the code that we would write. On the right-hand side, we have the code that Babel would spit out. We can see that const has been converted to var, since var is understood by a wider range of environments. And we can also see that our arrow function has been converted into a standard function, something that is also supported in a wider range of environments. So this is just one example of what Babel can do. We can actually teach Babel to do almost anything. If you want to learn more about how to configure Babel, you can head over to the setup or docs page, though we're actually going to go through that process together. Like I said, it's super simple. Install 2 things, add about 6 lines of code, and we're all done. So let's go ahead and actually knock that out from Visual Studio Code. For this course, I am going to be using the integrated terminal provided by Visual Studio Code. If you're on Linux or Mac OS, you're more than welcome to use that as well. If you're on Windows, though, I suggest using a terminal emulator so you can access the same commands that Mac OS and Linux users have access to. That'll make it easier to follow along with the videos. You can grab one of these terminal emulators, such as Commander, over at cmdercommander.net. Here, you need to download the application, run it, and when you do, you'll be brought to a new terminal window where you can access all of the same commands that I'm about to run. I'm also going to be using some keyboard shortcuts in Visual Studio Code for this advanced class. I recommend you get familiar with the keyboard shortcuts for your operating system as well. If you're not sure what a keyboard shortcut is for a particular command you want to perform, you can always search for it using the command prompt. So in the end of the day, the only one you actually need to remember is the command to show all commands. For me and my particular OS and setup, it is Shift-Command-P. You can go ahead and close all of the tabs to actually see this background panel and see what the keyboard shortcut is for you. Now I can search for something like toggle terminal, and I can see that for me, it is this keyboard shortcut. That is Control plus the backtick. So I'm going to go ahead and run that, and bam, the terminal pops open. So we will be using keyboard shortcuts for those operations. I recommend using the command palette to find the keyboard shortcut and then memorize it. Right here, we're going to start by changing directories into the GraphQL Basics project. CD space GraphQL-Basics. From here, we're going to generate a package.json file for this project, and we're going to install the 2 modules necessary to get Babel up and running. Since Node is a requirement for this course, you should be familiar with generating a package.json file and installing modules. I'm going to be using npm init to generate my package.json file for this project, and I'm not going to actually change any of the default values. So it's going to ask me for about 7 different values. I'm going to use the default one by just hitting enter about 7 or 8 different times. At the end, it asks me if this package.json file looks good. It does. I type yes, hit enter, and we're done. Now, all that command did was it generated our package.json file. We're going to have to run an npm installation command to get those 2 modules installed for Babel. So right here, I'll use clear to clear the terminal output, and we're going to use npm install to install those 2 modules. The first module we need is Babel-CLI. This is going to give us a new command that we can run to actually pass our code through Babel and have Babel compile it. I'm going to specify a specific version using the @ sign, so Babel CLI at 6.26.0, which is the latest. The other module we're going to need, which is actually going to process import-export, is Babel-preset-env. So this allows us to run a command to compile Babel. This tells Babel exactly what it should change. We're going to provide a specific version number for this one too, that is at 1.7.0, which is the latest. We can go ahead and run that command. That's going to get both of those installed. Then all we have to do is write about 4 lines of configuration code to tell Babel to use that env preset. So our import-export code gets converted correctly and is compatible with Node. We can add a single file to our project to get that done. You want to toss this in the root of the GraphQL Basics project. We need to call that one .babelrc. And in the end of the day, this is just a JSON file where we configure how Babel works. We're going to provide our root object with a single property, the presets property. So right here in double quotes, presets. The value for presets is an array, and we provide as strings the names of all the presets we want to use. In this case, we install just one, so we're going to provide just a single string in this array, env. Excellent. And there we go. Babel is all configured and ready to go for the rest of the class. Now, before we can actually run any code, we need to create a source directory and some sort of entry point for our application. I'm going to create a source folder in the root of the project called src. And in there, I am going to create the entry point for this application, and I'll call that file something along the lines of index.js. We can add some content inside of here, like a simple console.log call, just to make sure the file runs successfully. Right here, something along the lines of hello GraphQL or any other generic message will get the job done. The last thing we're going to do before we actually run this file is to make a new script in package.json that allows us to run things through Babel. So right here, I'm going to create a new start script. So I'll add a new property onto the start object. We will set its value equal to a string as well, and this string is going to be the following: Babel -node space, then the path to our file, source/index.js. Babel node is what we're going to end up using for local development purposes only. We'll talk much more about how to create and run this project in production later in the course when we actually deploy our projects live to the web. But for now, this is a fantastic way to get started. If we go ahead and save package.json, we can run that start script. Right here, npm run start. I'm going to run through the script, and what do we get? We get our little message showing up, hello GraphQL prints. So when we run that command, Babel grabs the file we specified, it passes it through the Babel compiler using the configuration we provided, then the output file is what actually runs. The output file isn't saved anywhere to our hard drive, it's just executed by the command itself. Now currently we're not using any feature that would be unsupported otherwise, so we're not getting any real advantage from Babel. That's all going to change though in the very next video when we start exploring the ES6 import export syntax. So as long as you're seeing hello GraphQL printing right here, you are all ready to continue on to the next lecture, and we're going to dive a bit deeper into how that syntax works because it's something we'll be using throughout the entire class. In this video, you're going to learn about the ES6 import-export syntax, which, like require, is going to allow us to break up our application into multiple distinct files. So instead of having one huge file, we can break up our app into many smaller files, each concerned with some sort of specific logical goal. This is also going to allow us to load in code from third-party libraries we install, which is something we'll be doing in the very next video when we install and use a GraphQL library. For the moment though, we're going to play around with this new syntax with a couple of local dummy files. So right here in the source directory, I'd like to create a new file. We can call it something like mymodule.js, and this file is going to contain some code that's necessary for index.js to run. So maybe I have a few functions or some objects or strings or whatever that I need to export over here and import over here. How exactly would we get that done? To kick things off, let's say that we want to actually create this string in my module. So I want to define the string over here. I want to export it. I then want to be able to import the string into this file and actually print it using console.log. How would we get that done? Let's start from a nice clean slate, nothing in either file. And we're going to start by adding some content to my module.js. I'm just going to create a new variable to store my message, const message equals. Then right here, we're going to define our message, some message from my module.js. Perfect. Now we actually have to export it. Creating the variable alone is not enough. We can use the export statement to get that done. How do we do that? We start with export. Then we set up a pair of curly braces and we list out, comma separated, all of the things we wanted to export. In this case, there's just a single variable in the file, so all we would do is list out message. If we had another variable called name, I could add comma space name to export that as well. But in this case, just one thing to export, so we'll add just one thing in the curly braces. Now this file is actually done. We've created our variable and we've exported it. In index.js, we're now going to import that file, grab that variable, and then do something simple like print it to the screen. Though later on, we'll be exporting and importing functions and calling those functions. The import statement has four major components. The first is just the import keyword. So right here, import. After that, we're going to open and close a set of curly braces, and we're going to list all of the things we actually want to import. So if I was exporting 60 different things over here, I might not actually need all 60 things over here. So I can list out just the stuff I want. We only have one thing to choose from, and I am going to go ahead and grab it. So I'll list out the variable right here. Message exactly matching up with what was exported. Message. Now you'll notice that this line has become gray. That's because we're actually not using message down below. It's just letting us know that we've imported something we're not using. We'll fix that in a moment when we actually use the message variable. After the closing curly brace, we have to provide the from keyword and specify where we're getting message from. In this case, we're getting it from the my module file. So right here, I'm going to open and close a set of single quotes, and we're going to define a relative path from index.js to the correct module file. So we'll start with // This is going to bring us to the same directory as index.js, which is the source directory. Since my module sits in the source directory, I can access it right here, my module.js. Now you can actually leave off the .js extension. It's the default extension and it's not necessary. So // my module gets the job done. Now we have this thing imported, but to make sure we're actually getting the correct value, let's go ahead and use it. Console.log, printing the message variable to the console. You'll notice that when I added this line got syntax highlighting since the content we're importing is actually being used. Let's go ahead and run this file down below. npm run start is going to run our script, passing it through Babel, and what do I get? I get the correct message, some message from my module.js. So there we go. We've seen our first import and export statement successfully working, allowing us to break up our application into multiple files. This particular type of export is known as a named export. So right here, I'll leave a little note, the named export. And it's called the named export because it has a name. There is a specific name we're exporting, and you have to import it by the same name. The nice thing with a named export is we can have as many as we like. Have as many as needed. So for example, right here, I could set up another const name. I could set it equal to the string Andrew. You can use your own name, and we could export that too. I could add that onto the list. So after message, comma, space, name, now this file is exporting two things. It would be perfectly fine if index.js just needed one of them. This is still valid code, but we can also choose to grab that second one if we wanted to as well. We grab it by its name. Then we could add another use of it down below, console.log, printing the name to the console. So now we're exporting two named exports, we're importing both of them, and we're using both, just printing them. If I save both files and I rerun things from the terminal, what do we get? We get two messages printing. We have some message from module.js first, then we have Andrew second. Aside from the named export, there is one other type of export we can have, and that is the default export. The difference between the two types of exports is that the default export has no name, and you can only have one. You can only have one. So let's actually see this in action. Down below, all I'm going to do is create a third string, so const. I'll call this something like location, and I'll just set it equal to a string that has my current city in it. I'm currently in Philadelphia, so I'll toss that right there. Now to actually export this as the default export, we have to modify our export statement. What I'm going to do is set it up like I would for a named export, so comma space location. Then we're going to tag it as the default by using as default afterwards. When we tag it as the default, we are choosing that one as our default export. Since we can only have one, I couldn't tag message as the default and also tag location as the default. I have to pick just one at most. Obviously, we already saw you don't need a default export, but if you are going to choose to use it, you can pick just one value. Now this file is all done. We've successfully set this up as the default export. Let's go ahead and move into index.js and see exactly what it takes to grab that value and use it. We're going to modify our import statement, and when we want to grab the default export, we actually give it a name right here after the import keyword. So I can pick whatever name I want, something like my current location. Then we add a comma if we're also providing named exports. So this would be an example of an import statement that grabs all types. We grab named, we grab the default. We could also choose to do something like this. Import my current location from ./my module. In this case, we don't need the comma because we're not grabbing any named exports. We're just grabbing the default export. This would be perfectly valid as well. In our case, let's stick with that first line where we grab all three. We've successfully loaded that in, and I'm going to go ahead and use it down below. Console.log my current location. Now you'll notice that the name I chose for the variable over here does not match up with the name over here. This is because, unlike a named export, the default export has no name. We are importing it by its role. It is because it's the default export that we're able to get the correct value over here. Let's go ahead and save all of our files. I'm going to rerun things from the terminal, and we should see our third message printing. I have the first two correctly, and I have the new third message correctly printing Philadelphia to the screen. Now remember, for these examples, I chose to export strings just to keep things simple, but in most cases, we would be exporting a function, so let's see an example of that too. I'm going to go ahead and set up a fourth export, so right here, const, and I'm going to call this one something like getGreeting. GetGreeting is going to be a function. I'll use an arrow function, and we are going to take an argument. I'm going to take in some sort of name. Now down below, what is the function itself going to do? All I'm going to do is return a template string. This string is going to use the name to generate some sort of generic greeting. I'll just have something simple like welcome to the course followed by the person's name. So right here, I'll add their name in. There we go. A very simple function. We take an argument, we return a string. Now we can set this up as a named export down below. Let's go ahead and do just that. So right here, getGreeting with a comma afterwards. We now have a completely valid export statement. I can save this file. We can actually load in getGreeting and call it over here. First up, let's go ahead and load it in. getGreeting. Then let's go ahead and use it. So I'm going to call console.log to print something. I'm going to print the return value that comes back from calling getGreeting. And since getGreeting does take a name, I will pass a name in. I'm just going to pass in the name Jessica. So I would expect in the end of the day to see the message, welcome to the course with Jessica printing. I'm going to save index.js, rerun things from the terminal, and what do we end up getting? We get just that. Welcome to the course, Jessica. So using the import and export statements, we can share values between our files, and this is something we're going to be doing throughout the entire course. In this video, we took a basic look at the syntax. We'll see more and more real-world examples as we move through the class. We'll also see examples where we load in things like functions from third-party libraries. Now it's challenge time, and for this challenge, you're going to be creating a new file like my module. You're going to set up and export a couple of things. You're going to use them in this file, and that'll make sure we actually understand how import and export work. Down below, I have a few comments for how to get this done. So for almost all challenges in this course, I am going to give you a list of steps you need to complete to make sure we're all at least on the same page. This is just a general guideline. The actual details, the code, are not something I'm ever going to give you in the steps. That's the whole point of the challenge. So here's the goal. The goal is to create a brand new file, export a couple of functions, and then import and use them over here. So step one, you're going to create a brand new file called math.js. In there, you're going to define two functions. The first, you're going to define an add function. This should take in two arguments and return the sum. So add them up, return the result. Step three, in that same file, you're also going to define a subtract function. So you'll take in two arguments, you'll subtract them and return the result. Step four, you're going to set up the add function as the default export, and you're going to set up the subtract function as a named export. Step six, from this file, index.js, you are going to import both of those functions, and then you're going to use them. So add up two numbers, print the result, subtract two numbers and print the result, making sure you're getting everything correct. The last thing to do is to actually run your file and ensure that you see the results for your addition and your subtraction operations. All right, take some time to pause the video, knock this out, then go ahead and test your work. When you're done, come back and click play. How'd that go? Let's go ahead and kick things off with step 1. We're going to create that brand new file. So in the source folder, a new file called math.js, and in there, we're going to define both add and subtract. So const add equals. Now, when it comes to the actual details of some of these challenges, it's not too important if you used something like the function or if you used something like the arrow function. If I didn't specify it in the challenge itself, you could really go either way just fine. I'm going to go ahead and use an arrow function though, and I am going to use the shorthand syntax for this simple function. So I'm taking in two arguments, a and b, and then I am going to implicitly return the result of a plus b. And I'll do the same thing for subtract. So right here, const subtract. I'm taking in two arguments, a and b, or z and y, or 1 and 2, whatever you chose to call them is perfectly fine, a minus b. Now that covers step 2 and step 3. Step 4 and 5, we want to set up add as the default export and subtract as the named export. So I'll use an export statement down below. Inside of curly braces, we'll set up add as default, then a comma space, and we'll set up subtract as a named export. So we just provide its name. And there we go. Everything in math.js is all wrapped up and ready to go. Over inside of index.js, we can move on to the last two steps. We want to import both of those new functions and then actually use them. So right here, index.js, I'll wipe all of the current file contents aside from the challenge steps. I'm going to use import to grab both of those things. We start off with the default export if we're actually going to grab it, which I am. I can call this whatever we like. I could call it add, but since it's the default, I could also call it my add function, which I'll do just to prove the point. Then a comma space if we are going to provide some named exports we want as well, which we are. And in this case, we just have one called subtract. Awesome. Last up, where are these coming from? Well, they're coming from the file we just created. So in single quotes, /, which gets us to the source directory. Then the file's sitting in right inside of there. So math, we don't need to add the JS extension since JS is the default extension it's going to look for. Now we can use both of them. Console.log, I'm going to call my add function. I'm going to pass in two numbers. I'll add up 1 and -2, resulting in -1. And then I'll do another console.log call for my subtract function call. Right here, I'm going to take 10 and I am going to subtract 2, the result being 8. Finally, you needed to test your work. So if I rerun things from the terminal, I should see -1 and 8, and that is exactly what I end up getting. So there we go. That is our first semi-real world challenge. The challenges, as these ones have shown, are going to get a bit harder as we go along. It's going to give you more to do to test your skills. With this in place, though, we now know the basics of the import and export syntax, and we're all done for this video. In the next video, we're actually going to install GraphQL and we're going to load it into our project so we can get started down the path of creating our very own GraphQL API. I'm excited to get to that, so let's go ahead and jump right in to the next one. You've spent a bit of time learning about GraphQL queries and you now have a great project structure in place. In this video, we're actually going to set up a GraphQL API. So by the end, you will have a real GraphQL API server up and running, and you'll have your own instance of GraphQL Playground that you can use to actually make sample queries to the server that you've set up. Now remember that using GraphQL Playground is just a temporary way to make sure our server is working as expected when we perform various operations on it. In a real-world situation, these queries would come from something like a mobile device, another server, or a web browser, and we'll talk about exactly how we can get all of that done later in the course. For now, we just want to get a GraphQL API set up. Before we install any NPM libraries, it's important to note that GraphQL, the graph query language, is just a specification for how all of this stuff should work. For example, how should queries work? In the end of the day, it's not an implementation. So it's up to individual developers to take this document that describes GraphQL and actually implement it for that environment, whether it's Android, iOS, JavaScript, Node, Python, C, Golang, or whatever. We need implementations of GraphQL to use it in those environments. So for our purposes, we have to find an implementation of the GraphQL spec that actually works with Node.js. Now that might seem like a weird concept, but it's actually the exact same thing we have with JavaScript itself. We have the ECMAScript specification describing how JavaScript should work. Then we have various implementations. For example, Chrome and Node use the V8 engine. We have Mozilla using SpiderMonkey. We have Microsoft using Chikara. So those are 3 implementations of the JavaScript spec. In our case, we just have to find an implementation that works with Node. Now you can actually view the spec itself over in the browser. If you head over to facebook.github.io/GraphQL, we can view all of the versions of the spec. We're just going to crack open the latest release really quick. And what do we get? We get a really long document. This document describes in detail how GraphQL should work. You know what you're not going to find here? You're not going to find any Node.js code. You're not going to find any Python code or any code other than GraphQL. This describes the graph query language. It's up to developers for those other languages, Python, Java, and Node, to actually create their own implementations. Now, in the end of the day, what does that really mean? It just means that we might have multiple options to pick from when we're using GraphQL in a specific environment. There might be multiple clients for iOS. There might be, and are, multiple servers for Node.js. The tool that we're going to be using to get GraphQL up and running on Node.js is GraphQL-Yoga, which we can install down in the terminal. You're more than welcome to use the Yarn package manager with this course. I'm going to be sticking with NPM. So npm install, which can be shortened to npm-i. The module GraphQL-Yoga, and I'll be specifying a specific version, the latest, at 1.14.10. We can go ahead and run this installation, and once it's done, what are we going to do? We're going to pull up the docs, and we're actually going to set it up in index.js. That means we're not going to need any of this code we had to learn about import, export. So I am going to wipe index.js, and I'm also going to delete math.js and the mymodule.js file. You're more than welcome to keep them around if you want, but they're not going to make it into the final version of this application. They were added for demonstration purposes only. Awesome. So we have GraphQL-Yoga installed. Let's go ahead and pull up the documentation so you know where that lives as well. I'm going to Google the library name GraphQL-Yoga, and we're looking for the GitHub documentation page. That's this first one right here. Now the question has to be asked, why use this particular tool? Well, I use this for all of my personal and professional client projects for 2 main reasons. One is that it provides the most advanced feature set, allowing us to tap into everything GraphQL has to offer. The second is that it comes with a very easy setup process, so we can get up and running very quickly, but we can also use the same tool to build advanced APIs with all of the real-world features we'd expect, like subscriptions, authentication, and more. Now on this page in particular, we can learn a bit about how to actually set up GraphQL-Yoga, although we'll be working through that in this video. And we can also learn about other ways it can be configured and used. There are various options available to us, and we'll explore a lot of these throughout the course as well. Where I'd like to start though is by moving into index.js and getting a bare bones version of GraphQL-Yoga up and running. I'm going to collapse the terminal, and we're going to start by using an import statement to grab something off of the GraphQL-Yoga library. We're going to grab the tool that allows us to create a brand new server. Right here, that is a named export, and it's called GraphQL Server. Note the capitalization here, as that is important. After we have the closing curly brace, we use from, and then we provide where it's coming from. If it was a local file, we would start with // Since it's an NPM library we installed, we just provide the library name, GraphQL-Yoga. Awesome. And that's actually all we need to import in order to get GraphQL-Yoga up and running. Now there are 2 things we have to define before we can start our server. The first are our type definitions, and the second are the resolvers for our API. These are both very important things, so let's take a moment to talk about what each are. To start, I want to talk about type definitions, also known as your application schema. The application schema is super important. It's where we define very important things like all of the operations that can be performed on the API and what our custom data types look like. Let's bring this back to a real-world example by heading back into the GraphQL playground for the demo API that I set up. Here, if we opened the schema tab, what were we greeted with? We were greeted with all of the operations we could perform. In this case, we only know about the query operation and we only have queries listed here. We have 7 different queries that can be performed. All of these were defined in the schema, and we're going to learn how we can set up our own queries too. The schema also defines what our data looks like, so our custom data types. When we queried for me, for example, what we got back was a user. A user had a specific set of fields of various types. This is also defined in our application schema. So the schema is super important. It is a very big piece to the puzzle. We also have our application resolvers, and your resolvers are nothing more than a set of functions. We're going to define functions that run for each of the operations that can be performed on our API. So for example, the demo API, I created a function for the hello query, for the course query, for the course instructor query, and for the me query. Those functions know what to do when that query runs. They know how to get and return the correct data. So these functions will eventually be where we query data from a real database, write data, or do whatever's necessary depending on what operation got performed. So we have our type definition. This describes the operations and the data structures. We have the resolvers. These are the functions that actually run when various operations are performed. Let's kick things off with our type definitions. Right here, I'm going to create a new const called type defs, and I'm going to set it equal to a template string. So here I'm using the backtick key to the left of the 1 key on my keyboard. Now what goes inside of here is GraphQL code. So we define our schema in regular old GraphQL, and we're going to start learning that syntax right now. What we're going to end up doing is defining just a single query. So we're going to set up our application so we can query for hello, nothing else. To do that, we start by defining the query type. That's one of the 3 built-in types. When we use the query type, we can define the queries for our application. So type, followed by uppercase Q query, which has to match exactly since it's built in. And then we set up our curly braces. Now, what do we do inside of here? We define all of the queries we want to support. So in the case of the demo app, I had 7 queries. I had 7 things defined in here. We're going to stick with just a single thing, a single query called hello. To define the query, we start off with the query name. In this case, hello. So I'll type hello out. Then we add a colon, a space, and we define the type that should come back when this query is executed. So we've explored the string type quite a bit, and we're going to stick with that for the moment. So right here, after our colon space, that's uppercase S string. Now that we have this in place, we have a completely valid type definition for our API. While it is a simple one, it is indeed going to get the job done. Now we can leave string like this if we want null to be able to be an option for the return value. We can always add on an exclamation mark to say that hello is always going to return a string, and that's what I'm going to do. So we're always going to get a string back. The only other thing we have to do is to define our resolvers. Since we only have a single operation, a single query, we're only going to end up defining a single function. Right here, I'm going to create the resolvers object. So const resolvers equals a new object, and in general, the structure of this object is going to mirror the structure up above. So we will start with an uppercase Q query property. This is also going to be an object, and on there, we're going to define various methods. One method for each query we've set up. We only have one query, so we're only going to define one method, and the names need to match. So down below, hello. I'm going to go ahead and use the ES6 method definition to define this method, and all we have to do is return a string. We have to return what the expected value is. So let's use return to return a brand new string, and I am going to say, this is my first query, perfect. Now, this resolver function does get called with some arguments, and we are going to explore those later. They're really important for real-world applications. For the moment, though, we're going to ignore all of those arguments, just returning a static string. Now, that is it. We have our one operation set up. we have the code necessary to get data back when that operation is performed, and we can go ahead and actually start up our server and query for that data. How do we do that? We do that with 2 lines of code down below. First up, we have to declare a server, so const server, and we're going to create a new instance of GraphQL server, which we imported up above. So new GraphQL server, and this does expect an object as its argument, and there are 2 properties we have to define. We have to define type defs, passing in our type definitions, and we also have to define the resolvers property, passing in our resolvers. Since the property name matches up with a variable with the same name, we can use the object property shorthand like this, passing in type defs and resolvers. The last thing to do is to use a method on server to start everything up. Right here, server.start. We are going to pass to it a callback function. This function runs when the server is actually up and running, and all we're going to do is use a little console.log to print a message. The server is up. Perfect. There we go. It is time to run our application. I'm going to crack open the terminal. I'm going to clear the terminal output and use npm run start to start things up. Now, by default, GraphQL-Yoga is going to try to start up the application on localhost port 4000. So let's head over there. In the browser, I'll make a new tab, localhost port 4000, and what we're going to end up seeing is an instance of GraphQL Playground for the brand new API we've set up. Now we can see that it's trying to save all of the requests from our other instance. All we need to do is close down all of these tabs. Then in a new tab, which points to localhost 4000, we're going to create our query. I am going to query for hello, which is the only thing that exists. I'm going to click that play button, and what do we get? We get our message. This is my first query showing up, and this is fantastic. We were able to set up our very own, albeit simple, GraphQL API, and we were actually able to make a query to the API, getting the correct data back. Now that we have these servers set up, it would actually be very easy to add other operations that someone could perform. We can add another query, for example. I am going to hit enter, set up a name query, :space, and we're going to have this one return a string as well. All we need to do to get this to work is to define a resolver for name. So right here, after the hello method, I will define the name method. We're not going to worry about any of the arguments for the moment, and I am just going to return my name as a string, Andrew Mead. Now we can save the script. I can go ahead and use Control-C to shut down the server, the up arrow key to reload that last command, and enter to rerun it. Then we can refresh things over in the browser and we can query for that new field. Right after hello, we're going to query for name. Now I can click that play button, or I can use Command Enter to rerun the current query. That would be, I believe, Control Enter for Windows users. And right here we have the latest information. I have hello and I have name. To wrap up this video, I would like you to add 2 more queries to our application. So right here, you're going to add a query for location, which is going to return a string, just has your location as the string. You could say something like your city name, for example. And you're going to set up a bio query, which also returns a string, and just add a quick sentence about yourself. So take some time to add the type defs for both of those queries and the resolver functions for each. Then restart your server, run a new query from GraphQL Playground, requesting both of those fields, and make sure you get the correct data. Take a quick moment to pause the video, knock that out, test your work, and when you're done, click play. All right, how'd that one go? I'm going to kick things off with my type definitions. That's where I like to start. So I will define the location query, which will return a string, and I'll define the bio query, which will also return a string. We'll get away from strings only in just a second. Then we're going to remove those challenge comments, and I am going to move on to the resolver definitions. So down below, after name, comma, enter, we have to define 2 new methods for our 2 new queries. First up, location. Not worrying about any of the arguments for the moment and just returning a static string. For me, that would be still Philadelphia. After location, comma enter for 1 more method for bio. We're going to set up that method. I'm going to return a quick bio. I live in Philly and teach on Udemy. Very exciting stuff. Now we can go ahead and actually save index.js. I can restart my server and we can refresh the browser to make our brand new query. Right here, we have hello, we have name, I'm going to add on location, and I am going to add on bio. Command enter to rerun the query, and what do we get? We get all 4 fields returning the correct data. If I crack open the schema, we can see that we are getting exactly what we would expect. We have all of the 4 queries we set up described right here. So now we have a setup we can continue to expand on, and what I want to talk about in the next video are the other types we can use in GraphQL. It's not all just about strings, we have numbers and booleans too. We're going to tackle that in the next one, so stay tuned and I'll see you soon. In this video, you're going to learn about the other types that come with GraphQL. It is not just strings, despite what you might think based off of what we've actually used so far. There are actually 5 main types that I want to talk about in this video. Right here, we're going to list out all 5. And you can always refer to the PDF guide for this video to get the exact list so you don't have to write all of this down. The first type we have is the string. The string type, as we've already seen, stores our string-based data. We also have the Boolean for storing Boolean values. This is great for things like an isPublished field, where the value is either the Boolean true or the Boolean false. In GraphQL, we can also represent numbers, and there are 2 types for that. First up, we have the int for storing integers. So for storing whole numbers, like your age, 27, or something like the number of products you have in stock. Maybe you have 14 somewhere in the warehouse. After int, we have float, another way to represent our numbers. This is great for numbers with decimal points, like a GPA, 3.17, for example, or something like a ratings system where a product has been rated 4.7 stars by customers. Last up, we have the ID, that is capital I, capital D, and this is a bit unique to GraphQL. It's used to represent unique identifiers. In the end of the day, it is very similar to a string, but we'll explore the differences as we progress through the course. Now, these 5 types are known as the 5 scalar types inside of GraphQL. A scalar value is just a single discrete value, so a scalar type is a type that stores a single value, whether that value is a string, a boolean, an int, a float, or an ID. This is the opposite of a non-scalar type like an object or an array, which is a collection of discrete values. So with an object, we have many properties. With an array, we could have many elements in that array. We'll be covering objects and arrays very soon. For the moment though, in this video, I just want to focus on these 5 types, and we're going to do that by setting up 5 queries, 1 for each type. Let's go ahead and remove our existing 4 queries from our type definitions and from the resolvers down below, and we're going to set up 5 new ones. And all 5 of these are going to be things that could describe a person. So for example, we're going to have an ID, a unique identifier for that person, and the type is going to be the ID type. So uppercase I, uppercase D. Now for almost all of the fields we set up, we are going to want to use the exclamation mark, saying that this is something that should always return an ID, as opposed to being able to return null. Now after ID, we might have something like name, and in the case of name, we could use the string type we've already explored before. After name, let's say we want to represent the person's age as an integer. So right here, age, colon space, uppercase I int with an exclamation mark on the end. Next up, we can use a Boolean to represent whether or not that given person is employed. So right here, we could set up the field employed. I could have its value be a Boolean, and we'll use an exclamation mark to make sure we always get a Boolean back. You're either unemployed or you are employed. Down below that, we are going to have our final value, and this is going to be the GPA. Now the GPA is going to be stored as a float because my GPA could be something like 3.17, for example, and I'm actually going to leave the exclamation mark off. If I'm not a student, I'm not going to have a GPA, so it's okay if I get null back. This basically says it's okay if I get null, but if I am sending back a non-null value, it has to be a float. So we have all 5 queries set up. Let's go ahead and create resolvers for each. I'm going to start with a method for ID. After ID, we have name. After name, we have age. Then we have employed, our Boolean value. And finally, we have GPA, the one that is optional. So we could return null from here if we wanted to. Now, for the moment, you'll notice that we have individual resolver methods for individual properties on something like a user. This is only temporary. Once we learn about our custom types, where we can actually model a user, a post, a comment, or whatever else makes sense for our application, we'll be reducing the number of resolvers. So this is just a temporary thing. We will address this shortly. For the moment, though, to mess around with all of the scalar types we have access to, let's go ahead and return what each expects. So in ID, I am going to return a string ABC123. I could also choose to return a number like the number 12, for example, but at the end of the day, that will get converted over to a string, so it'll look more like this. I'm going to stick with an actual string ABC123. For name, we are obviously returning a string, something we've done plenty of times before, not much to say there. For age, we are going to go ahead and return an integer. So I'm going to return 27. For employed, we want to return a Boolean. So I would return true if I was employed or false if I was currently unemployed. I am self-employed, which is definitely a type of employment, so I'm going to go ahead and return true. Last up, we have our GPA. Now with the GPA, yes, we could return something like 3.1, perfectly valid, a perfectly valid float. But we could also choose to return null, because remember, for this type definition, we left off the exclamation mark. This is saying, I expect a float back, but it would also be fine if you gave me null. This is saying I expect a Boolean back, and because of the exclamation mark, it's saying you have to return a Boolean. You can't return null. Since I currently don't have any sort of GPA, I'm not in school right now, I am going to go ahead and return null. Now that we have all 5 set up under both our type definitions and our resolvers, let's go ahead and save the file, restart our server, and test things out. I'm going to shut the server down. I'm going to start it up once again. Over inside of the GraphQL playground, I will give things a quick refresh just to update that schema. And we're going to update our query. I want ID. I'd like name, spelled correctly, of course. I would also like age. Then we have employed. And finally, we have GPA. I'm going to fire that query off, and what do I get back? I get back all of the correct values. ID, we have our string. Name, we have Andrew. Age, we have the integer 27. Employed, we have true, and for GPA, we have null. For GPA, remember, we could have also returned a float. So over here, I could return something like 3.01. That would get the job done. If I save the file and restart the server, we can actually query for that data. So it's perfectly fine to have null, but as we can see now, it's also perfectly fine to actually return that float. So there we have it. These are the 5 scalar types that we can work with inside of GraphQL. Now, as your challenge for the video, I'd like you to go ahead and add a couple more into the mix. Up above, I have a few comments for what I'd like you to do. So right here, you are going to be creating a query definition, and a resolver for each of these 5 properties. Now, in this case, let's say we're modeling an e-commerce store. So we have titles for our products, we have prices, release years, ratings, and whether or not that product is in stock. And we want to represent all of these using some of our scalar types. So the title, for example, is going to be a simple string for the product name, and this one is going to be required. You have to have a title. For the price, we're going to say this is a number represented as a float, so the price could be 9.99. We're also going to have an optional release year represented as an integer. So whether or not it makes sense for your product is up for you to decide, because it is, in the end of the day, optional. We also have a rating, which is a number stored as a float. Your rating might be 5.0 or 3.64, and it's also optional. So when your product first goes up, we're not going to return a rating like 5 or 0. We're going to return null, just saying there is no ratings yet. Last up, in stock, that's a Boolean. If it's true, the product's in stock. If it's false, the product is not in stock. Now it's up to you how you want to approach this. You are more than welcome to keep all of these in place and then add these alongside. You can also go ahead and just clear all of your queries, and all of your resolver functions and build up from scratch. Either way, it gets the job done. So take some time to knock this out and test your work. Save the file, restart the server, and actually query for all 5 of these over inside of the GraphQL playground. All right, pause the video, knock this out, and when you're done, come back and click play. How'd that go? Let's kick things off by setting up our query definitions for all 5. So first up, we have title. Title is going to return the value of a string. It's required, so I'll toss an exclamation mark on the end. We also have price. Price is going to be stored as a float, and price is also not optional, so I'm going to be putting an exclamation mark on there too. We then have the release year. The release year is completely optional. When it is provided though, it's going to be represented as an integer, so right here, int. Next up, we have the product's rating. The product's rating is stored as a float. This is also optional, so I'm going to type float with no exclamation mark at the end, allowing null to be the value for rating. Last up, we have in stock. A product either is or is not in stock. This one is going to be a required Boolean. Excellent. So we have all 5 type definitions. Now we can actually move on to the resolvers down below. So we're going to start off with title. And for title, I'm going to return some sort of product name. I'm going to return a string, and I'll just use a book on my desk as the product. That is The War of Art. It's a great book about your inner creative battles and overcoming that stuff to get back to work and get productive and release the stuff that you want to release. It's a great book. After the title, we're going to set up the price. Now for the price, this could be anything. I don't know what this book actually cost. Let's just go ahead and say it costs 13 bucks. So I will return 12.99. After the price, we have our release year. Release year. I could dig into the book and see what the release year is, but I'm going to go ahead and just return null, since remember, the release year is completely optional, so returning null is valid. After release year, we have our rating for the book. I definitely enjoyed this one, so let's say that it has a 5-star rating. So right here, I'm going to return 5. The last one, whether or not the book is in stock. In stock, I'm going to go ahead and say this book is in stock, so I will return true as opposed to false for the book being out of stock. Now we have all 5 set up. We can remove the challenge comments. I'm going to go ahead and save this file. Down below, we will restart things from the terminal, and then we're going to query for all 5 in GraphQL Playground. If we get the correct data back, we're all done. So right here, we're going to change up that query a little bit. First up, I will refresh the page to grab the latest schema. I'm going to access the title. I'm also going to grab the price. I'll grab the release year, even though we know the release year is going to be a null value. After that, we have the rating for the book, and then whether or not the book is in stock. If I execute that query, what do I get back? I get back all of the data that I just set up. We have our title, The War of Art. We got our price, $12.99. We don't have a release year. We have our 5-star rating, and the book is indeed in stock. So there we go. You now know about all of the 5 scalar types that we can work with inside of GraphQL. What we're going to cover next is how we can create custom types to model the real-world things that make up our application. So in this case, we might have a product custom type for all of these 5 fields. In the case of the fields we had earlier, we would have something like a user custom type. And that's going to make it way easier to maintain and scale our applications. No longer will we need 5 functions for 5 simple pieces of data. We'll be able to return everything that a custom type has with just a single resolver. Now, we're going to get to that in 2 videos' time. In the next video, which could be considered something like a bonus, I'm going to show you how we can automatically restart our server whenever we make any changes to our application code, so we don't have to manually restart it every single time we make a change. Let's go ahead and jump right into that. In this video, we're going to take just a few moments to make some changes to our local development environment to make going through this course a bit easier. So we're going to set things up to automatically restart the server anytime we make any changes to our application code. So if I change how my type definitions work, for example, I won't need to manually shut the server down and start it up again. It'll just automatically restart in the background. So if I have typos like I do right here, I won't have to restart things. I have is stock, that should have been in stock, and it should have been in stock down below. But when I save my changes, what happens? nothing happens. I have to remember to manually restart things. And when you're quickly iterating in development, so locally on your machine, that can be a real burden. Now to fix all of this, we're going to be using a very popular NPM module called NodeMon. That's going to allow us to start up our application and restart it when any of its files change. Let's head over to package.json and actually set this up. In the end of the day, we will be doing just two things. We will install one new module, NodeMon, and we're going to make a change to the start script. That's it. We don't have to make any changes to index.js to get this automatic restarting feature set up. Down below, I am going to shut down the server. I'll use clear to clear the terminal output, and we're going to be using npm install to install NodeMon. I am going to install the latest version, that is at 1.17.5, and I'll also toss on the save dev flag to save this one as a development dependency, something not necessary in production. Once we run this command, it's going to go through that installation process, and as I mentioned, the only thing we're going to end up doing now is changing our start script. Instead of running the Babel node command, we will be running the NodeMon command. So let's take a look at how that's going to go. While the command will look similar, it'll be different enough where I am just going to start from an empty command, and we start off with NodeMon. Now, NodeMon expects the file that you're going to actually run, so the starting point for your application. For us, that is still source/index.js. Now, this alone would normally be enough, but since we're using Babel, it's not. We also need to tell NodeMon that when it actually runs our file, it shouldn't just run it through Node, it should run it through Babel node. We can do that by specifying the ES6 argument. So by default, it looks like this. We run the file through Node, but we don't want that. We want to run it through Babel node. Perfect. So what's this going to do? It is going to start up our application by running this file through Babel node. NodeMon is then going to continue to watch our application files for changes. If they ever change, it's going to restart the server, running the new file through Babel node once again. And there we go. We have everything all set up. We can save package.json and actually test this out. Down below, I'm going to use clear to clear the terminal output. Then we'll use npm run start to start things up. When we run the command, what do we end up getting? We get a little extra output. We get some output from NodeMon telling us exactly what it's doing. Now, at the end of the day, though, we do still get our "this server is up" message, which means in the background, we can still run things. Now, remember, I changed that typo in my schema. I had is stock instead of the correct in stock, and you'll notice that over here, things haven't updated. You can either, once again, manually refresh the page, or you can just click this little guy, keeping all of your data in place, but just refreshing the schema, and now we can see it's invalid, and I can switch it over to the valid in stock, run things, and everything is working as expected. Now, as we iterate on our application and actually make changes, we can see those changes quickly. We can actually collapse the terminal since it's no longer something we're going to have to use every single time we make a change. For example, I can change the release year to something like 2008. I don't really know what year the book was released. Let's just say that was it. Over here, without making any changes to restarting the server, I can save the file, click that play button, and I get my new data showing up. So that's all I wanted to talk about in this video, just a slightly better setup for our local development, allowing us to work on the GraphQL part of the application and not have to manually restart things in the terminal. In the next video, you're going to explore how you can create your own custom types. I am super excited to get to that. That's where things are going to start to get a bit more real world. So let's go ahead and jump right into that. In this video, you're going to learn how to use custom types in GraphQL. So we're going to see what it takes to create our own custom types, allowing us to model the data that makes up our application. So if we're working with a blogging application, we're going to have custom types for all of the different types of data we have. We might have a custom type to represent a user, another one to represent a post, and a third one to represent a comment, where each has its own set of fields. So a user would have something like a name and an email, a post would have a title and a body, and a comment would have something like the comment text, and maybe when the comment was created, or who the comment was created by. We've seen a little of how these custom types work when we messed around with queries using the demo API earlier in the course. We saw that some of our queries send back scalar types. These three, for example, send back strings. But other queries like me send back custom types, allowing us to send back what's essentially an object, a set of fields. So me, for example, if we explore it in the schema, sends back a custom type user. This user has a set of defined fields. Here we have some scalar values, and we also have some relational data. So let's go ahead and see what it actually takes to create a custom type. In the end of the day, all we really need to do is define something new inside of our type definition. Our type definition starts off with the type keyword, and then we go on to pick a type name. And this name is completely up to us. So if we're creating an application that models blog posts, I might use post. If I'm creating an application that models products, maybe I use product. In this case, the first custom type we create is going to model a user, so I'm going to call this one user. And notice the uppercase first letter. We are going to have an uppercase first letter for all of the types that we define in GraphQL. Now down below, what do? We define the fields that make up this type. So what fields do all users have? In this case, we could say all users have a unique ID, a name, and an email, and that's exactly what we're going to set up. 3 fields for the user type. Now to kick this process off, it looks very similar to what we did above with our query definitions. I'm going to specify a field that a user has. Let's call this one ID, then colon space, and I go on to pick the type for it. So in this case, we will use the ID type, and I will add an exclamation mark on there. This is a required field. Now, next up, just hitting enter, we can add a second field onto all of our users. This one could be a name. So name, the value will be a string, and this one will always exist as well. And then we could add a couple more into the mix. Let's add an email to all of our users. We'll have that be a string, and then we'll add an age on as well, and we'll allow the age to be optional. So we'll set it equal to an int, but I will not use an exclamation mark. And there we go. We have our very first type definition. We have our user type, and we have the 4 fields that make up a user. Now we can actually take advantage of this type throughout our application. And for the moment, what we're going to do is create a query that returns a user. So let's go ahead and empty out all of our resolver methods and all of the queries we have set up. And we're going to create a brand new query, and I'm going to call this one me. Now later on, once we set up authentication, me is going to return some information about you, the logged in user. For the moment though, we're just going to return some generic information about a user. So right here, we set up our query, we're calling it me, and now we move on to the type that me is going to end up sending back. In the past, we only ever used scalar types. So I would add string, I'd add boolean, int, float, ID, those sorts of things. Now though, we can use one of our custom types, in this case, user. So we reference it by its name, and once again, we can decide if we want this to always come back or to allow it to be nullable. So right now, me could be null. If we add an exclamation mark on, we're saying that you're always going to get a user back. Let's go ahead and keep the exclamation mark in place, letting us know that me is always going to return something of the type user. So we have our type definition all set up. We have our query in place. We have the custom type created. Now all we need to do is set up a resolver. And since we only have one query, we're only going to have one resolver method. Right here, me, we're going to set it up. And what are we going to do? We are going to return something that matches up with the user type. So in this case, we're going to return an object with all of the fields that match up with the user fields. Now this is typically where we would go off and we would actually fetch some data from the database, but for the moment, until we get to that part of the course, we're going to stick with static data just defined in this file. So I can go ahead and return a new object and have the object properties match up with the user fields. So I need the first 3, the last one is optional. I'm going to set up the ID right here, matching up with the field name exactly. I'll give that a value of 123098. Then we can add on the other fields like a name. I will use a different name like Mike, and the email for Mike, which I will have as mike@example.com. And finally, the age. The age is completely optional, so I could actually go ahead and leave that off. This is perfectly valid. I could also choose to go ahead and add it on, setting the age equal to something like 28. And there we go. we have our very first query that returns a custom type. Let's go ahead and save index.js and actually test this out. I am going to refresh the schema to get the latest updates from the server, and we can see that none of these queries exist anymore, so let's go ahead and delete all of them, and we are going to use the one and only query we actually have, me. We're going to set up the me query, but remember that this alone is not enough. When we are querying data in GraphQL, we have to be specific down to the individual scalar values. So when the query returned a scalar value, this alone would be enough. We saw that with all of these examples over here. In this case, though, me is not returning a scalar value. It is not returning ID, float, ID, Boolean, or string. It is returning something of the type user. So if we have a non-scalar value, we have to provide a selection set for it like we did before. So we open and close our curly braces, and we get down to the actual scalar values we want. Maybe I just want the ID, in which case this alone is enough. I can run the query, and what do I get? I get my user's ID back successfully. I could also choose to grab all of the other fields on me. I could grab the name, I could grab the email, and I could even grab the age, whether or not it's actually something that exists. If I go ahead and run this query, what do I get? I get my ID, Mike at example.com, and age all printing to the screen. Now, if the age was not there at all, what would we get for age? We would get null. So I'm going to go ahead and remove age completely from the object that we return. I'll save the file. Over inside of GraphQL Playground, all we have to do is rerun the exact same query, and this time around, we successfully get age as null. And that is indeed correct. Now, if we tried to leave off one of the other properties, one of the properties that actually needs to be there, we would get an error related to that. For example, if we leave off email, which has been flagged as something that we have to have, we are indeed going to get an error. I run the query, and what do I get? I get an error. Cannot return null for non-nullable field user.email. So here we are looking at the error structure, and in general, the important piece to the puzzle is the message, the English readable message, allowing you to know exactly what went wrong. Here it's just saying that you tried to return null for user email. That's not okay. So we would be able to go into our code and actually address that, whether it meant adding data here or removing the requirement up above. For now, I am going to keep the requirement, and I am going to continue to send an email back, resulting once again in a completely valid setup. Now you'll notice throughout the course, I haven't been using semicolons to terminate my JavaScript statements. So for example, I don't have a semicolon here, or here, or here. This is all a matter of personal style choice. So semicolons are optional in JavaScript. We can rely on automatic semicolon insertion. Sure, there are some places where the semicolon still plays a role, like in the for loop, for example. I'm still going to set up my for loop with a semicolon in between, like the one right here. But when it comes to actually terminating lines with semicolons, it's all a stylistic choice. I've been on teams that force you to use semicolons. I've been on other teams that force you to not use semicolons when they're not necessary. So I'm going to be sticking with this semicolonless JavaScript. I recommend giving it a try if you've never tried it before. I've been hooked on it for about a year now, and I am never going back. All right, with all of that said, let's move on to the challenge for the video. What you're going to do is create a brand new custom type. Then you're going to set up a query and a resolver for that. So up above, I am going to leave some comments for what I'd like you to do. So step one, you're going to be creating a brand new post type. This is another type we're going to need for our blogging application. And you're going to add the following fields: ID, title, body, and published to this post type. Now, all of them should be non-nullable, so they should all have that exclamation mark after the actual scalar type definition. And we can have the ID be an ID, title and body can be a string, and published can be a Boolean. Next up, you're going to define a post query that returns a single post, much like we did for me returning a single user right here. Step 4 is to set up a resolver method to return some post data, just like we did for me down below. So you want to return an object that has all of these fields on it. Step 5 is to actually test the query out. So make sure to save your work, head over into GraphQL Playground, and make sure you can query for a post and get some of the post fields back. So take some time to knock this one out. When you're done, make sure to test your work, pause the video. When you're done, come back and click play. How'd that one go? I'm going to kick things off with my custom post type definition. So right here, type, uppercase P, post. We then set up our curly braces, and this is where we define all of the fields that make up a post. First one, ID. Almost all of the custom types we create, well, actually not almost, literally all of them, are going to have an ID field. They're going to have a unique identifier. So right here, of the type ID, and this one will be marked as non-nullable. Next up on our list, we have the post's title, a non-nullable string, and the post's body of the same type, a non-nullable string. And last up, we have whether or not the post is published. That is via the published property, a non-nullable Boolean value. Excellent. So we have our post type definition all set up. Now it's time to actually use it. To do that, we're going to set up a new query. That was step 3. So I am going to set up a query for post that returns a single post. So I have to reference the custom type by name, and I will make sure that it is non-nullable, so I always get a post back. Step 4 is to set up that resolver method to return some post data. So down below, we have to set up a resolver for all of our queries. We don't have one for post. Let's go ahead and create it. Right after the closing curly brace for the me method, I'll add a comma, move to the next line, and set up another method for post. Once again, ignoring the fact that there are arguments that get passed here, but we're just not using them. We'll actually start exploring those in the very next video. For now though, what do we have to do? We have to return an object, and this object needs to have all of those fields. So we need an ID. I'll use the ID of 092. We need a title. So title could be something like GraphQL 101, a post about how to get started with GraphQL. We need a body. The body could be a string that's just completely empty. Maybe I haven't started working on the post yet. And lastly, whether or not the post is published via the published property. I don't have a body for this one, so we'll say it's not published. I'll set the published value to false. Now that we've successfully returned the information necessary, we can actually save index.js, refresh the schema in GraphQL Playground, and make a query for the post. So right here, we see it alongside of me. I'm going to tack it on after me, trying to grab post. Remember that post does not send back a scalar type, so we have to provide our selection set. What scalar fields do I want from the post? I want the ID, I want the title, I want the body, and I want whether or not the post is published. Perfect. I'm going to collapse the schema panel, run this query, and what do I get? I get all of the expected data. On data, I have me and post. Inside of post, I have the correct values for all of the 4 fields requested. If I chose to not access one, like body, for example, that would be gone. I would just get the 3 I actually accessed, my ID, my title, and whether or not the post is published. So at this point, we can see how we can start to model our application in terms of these custom types, but there are still a lot more questions we need to answer. For example, how do I work with lists? So how do I work with an array of posts? How do I set up relationships between these? A user owns posts, and a post has an author. All of that is coming up in the next several videos. We're going to continue to explore these custom type definitions. For now, though, we are all done. I'm going to remove the challenge comments from up above, save the file, and I will see you in the next one. In this video, you're going to learn all about GraphQL operation arguments. This is going to allow us to pass data from the client to the server. So far, all of the data has been flowing in the opposite direction. So it's been going from the server to the client. But there are plenty of examples of why we would want to get data from our client to the server. Imagine I'm creating a front end for this blog application. The first thing I'm probably going to do is show them something like a sign up form, where I ask them for their email and their password. Once I get those pieces of information from the user on the client, I need a way to pass those through to the server, so the server can actually save a new record to the database, for example. Another reason I might want to use operation arguments is if I'm trying to filter some data. So imagine I have a query that returns all posts that someone could read. So all public published posts. Now that could be a lot of information, so someone goes ahead and they use the search box to search for a keyword like GraphQL. I want a way to get that keyword, that string, from the client over to the server so the server can use it to filter posts. Maybe I search for that keyword in the title and the body, only returning the post if I find it somewhere in either of those. So there are tons of different reasons why I would want to get data from the client to the server. Let's go ahead and take a look at how we can do that by exploring operation arguments, and we're going to start with a very simple query to explore this syntax. We still need to name this query, and I'm going to call this one greeting, and greeting is going to return a non-nullable string. Now, by default, greeting is going to return a generic message, something like hello, but we are going to allow the user to pass their name along with the query. If they do, we'll include that in the query as well, saying something like hello Andrew or hello Kate. So to kick things off, we have to determine what arguments this query should accept, and we do that inside of a set of parentheses right here, right between the query name and the colon. In here, we define all of the arguments that could be passed along with greeting, so we have to define all of the required ones, if any, and any potential optional ones. Everything has to be listed inside of the definition for greeting. In our case, we're going to have one. It's going to be an optional string. Someone can optionally provide a name. If they don't, that's fine too. The first thing we have to do is give a name for the argument. I'm going to call this one name. If I was trying to pass along the age, I would call it something like age. So we have the name argument. Then we use a colon and a space, and we have to be explicit about what type we are expecting. Are we expecting a Boolean for this value? No, we're expecting a string. So we will use the string scalar type. Now, if we were going to force them to provide a name every time greeting was used, we would put an exclamation mark after the type. In this case, without an exclamation mark, we're saying that it's perfectly fine to use the greeting query without providing a name. So that is it for the query definition. Here, we've determined that the greeting query has one optional argument name. Down below, let's go ahead and actually set up the resolver method for it. Right here, greeting. I'm going to set up my arguments. I'm going to set up the function body. I'll toss the comma right there. And for the moment, I'm just going to return a generic static message. Return, hello, perfect. Now let's go ahead and figure out what it takes to provide name when we're querying over inside of GraphQL Playground. I'm going to go ahead and save index.js. Over here, we can start by just grabbing greeting and making sure at least that works. If I run this query, what do I get? I get my data back. I get my static hello message. When we want to pass data along with one of our operations, we use parentheses right after the operation name. Then we specify all of the arguments we want to provide. Now, in this case, we don't have to provide any arguments. We saw that work because the only one that's there, name, is optional. But if we do want to provide it, we set up the parentheses. We determine the key we are trying to set a value for. In this case, I am trying to set a value for the name argument, then a colon space, and we actually provide that value. If it was a number, I might provide 12. Since it's a string, I am going to provide a string value. In this case, I will just use the name Jess. So now we are successfully passing a value, the string Jess, along from the client to the server. If we run the query, what do we get? We get absolutely no change in the response. Yes, the data is getting passed to the server, but it's now up to the actual resolver method to use the data to make some sort of dynamic response. Later on in the course, we'll be using data to query the database, to save records for the database. For now, though, let's just go ahead and use the argument to change the string that gets sent back. Now, the data that was provided, in this case the name Jess, lives in one of the arguments for our resolver function. There are 4 arguments that get passed to all resolver functions, and they are as follows. The first is parent. Parent is very common, and it's useful when we're working with relational data. So for example, if a user has many posts, the parent argument comes into play when figuring out how to get a user's posts. We'll touch on that in just a little bit. The next argument, called args, this contains the information we need. This contains the operation arguments supplied. The third one, known as context, which is typically shortened to CTX, is very useful for contextual data. So if a user is logged in, context might contain the ID of that user so we can access it throughout the application. We'll be doing just that later in the class. The last argument is info. Info contains great information about the actual operations that were sent along to the server, and we're going to be exploring that as well. But as I mentioned, the only one that's really important for us at the moment is this one right here, args. Args is an object and it contains all of the argument values provided. So let's go ahead and just dump args to the console. Console.log args. I am going to save index.js. I will crack open the terminal, and all we're going to do is send that exact same query across. I click the play button. Over here, what do I have? I have an object with the name property, and the value of that is the string Jess. So this is where my data lives. Now I can actually use that to provide a dynamic response. Right here, I'm going to use an if statement to check if args.name exists. And since it's a string, this condition will also make sure that this code only runs if it's a string that actually has content. So if the name is provided and it has real content, it's not just an empty string, we are going to return the following. Using a template string, I will say hello, comma, then right here, I am going to interpolate their name. So that's args.name. And at the very end of the string after their name, I'll toss in the exclamation mark. I can still return the generic message as well. Right here, I will set up an else clause, else return exactly what we had before, where I return the hello string. So now we are getting some arguments passed in. If they are provided, we do one thing. If they're not provided, we do something else. I'm going to save index.js. Once again, I am going to run that exact same query, and this time around, I get hello Jess printing. If I were to query for greeting and leave the arguments off as expected, I would get my generic message, hello. So there we have it. This is how we can pass data from the client over to the server. In this example, we happen to just have a single argument, but that's by no means a limitation. I could provide more if I wanted to. Right here, after the first, I can add a comma space and define a second. I could call this one something like job or position. And I can pick a type for this one. I'll make this a string as well, and then we can choose to use it down below. So maybe I check if the name is provided, and then I use the logical AND operator to check if the position is also provided. If they're both provided, I use the following message, hello, their name, then after the exclamation mark, another sentence, you are my favorite, followed by their position. So right here, we will add in args.position. Now I can provide both of these arguments to see my more elaborate message actually sent. Whoops, sorry for jumping around right there. I'm going to save index.js. Over inside of GraphQL Playground, I am going to also add the position on. So comma space, position, setting it equal to another string. And for this one, I'll just call myself a teacher or developer or whatever like that. Now you'll notice once again, we have to refresh the schema in order for this argument to become valid. Once it is added on though, I can click play and I get my message. Hello, Jess, you are my favorite teach. That should have been teacher. And while I'm at it, I might as well change it to the correct name, Andrew. There we go. So we have two arguments being passed to greeting, and greeting is able to use both of them because we actually use the args object here, and we've defined them up above in the query definition. That's where we're going to stop for this one. Let's move into challenge time, where you're going to be creating a new query that also accepts some arguments. Right here, there are 3 steps for getting this done. First up, you're going to create a new add query that returns a float. Then you're going to set up add to take 2 arguments, A and B, which are required floats. And you're going to have the resolver send back the sum of the 2 arguments. So in the end of the day, I should be using the add query over here, passing in A and B instead of name and position. Both of them should be numbers. Then the actual resolver is just going to add up those 2 numbers and return them. So I would expect to see the sum in the response. So if I passed in 1 for A and 2 for B, I would expect to see the total 3 come back. So you're going to have to define the query with the correct argument definition. You're going to have to set up the resolver that actually looks for those arguments and returns the sum. And then you're going to have to test your work by creating a query for that and actually running it, making sure you get the correct response. Once again, if you have any trouble going through this, you are more than welcome to refer to any code we've written, any videos you've watched, or any external resources. Take as much time as you need to work through this. If you get stuck, try to debug, then come back and click play. How'd that one go? We're going to kick things off by creating the query definition. So right here, we're going to call this one add. Add is going to return a float. Now we do want some arguments for add. That's the whole point of this challenge. And we actually want two. We want A and B. Both of them are going to be required floats. So A right here is going to be a float. We put an exclamation mark on there to ensure it's provided. And the other one, B, is also a float, also non-nullable. So the query definition is in place. Down below, we can actually set up the resolver for add. Add. We set up the method. We are also going to define our arguments. So we have the parent, we have our args, we have the context, and we have the info. You don't need to list out all four of them. I'm listing out all four as a habit since this is something we'll be doing later in the class. Right here, it's time to use the values. So we know they're going to be there. So I can return args.a plus args.b. And that is all we have to do for the resolver. And that is actually it for the index.js changes. I'm going to save this file, and over inside of Playground, I will actually make the correct query. I'm going to query for add. I'm going to pass in the two arguments it expects. A, I'll set that equal to 12, and B, I'll set that equal to -1. And there we go. We just need to refresh the schema to validate all of that. Now we can actually fire that off, and what do I get back? I correctly get back 11. If I were to change that to 1 and 2 and send the request off, this time I get back 3. So this is what you should have been able to get done using operation arguments. All right, that is it for this video. We now know how to use operation arguments, and that's going to allow us to actually use these arguments in a real way. In the next video, we're going to start focusing on how we can work with array-based data, and arguments are going to come in handy for that. Because as mentioned in the beginning of this video, arguments will allow us to do things like filter that data, sort the data, or do whatever else we might need to do. I'm excited to get to that, so let's go ahead and jump right in to the next one. In this video, you're going to learn how to work with arrays in GraphQL. This is going to allow us to exchange arrays back and forth with the GraphQL API. So maybe the client needs to send an array as one of the values for an operation argument, or maybe the server needs to send an array back as the response for a given operation. In either case, we can do just that using arrays. Now to start off, we're going to explore how we can work with arrays of our scalar types. So an array of strings or an array of numbers. Then we're going to move on to a more real-world example and learn how we can work with arrays of our custom types. So an array of posts or an array of users. To kick things off though, we are going to start with those scalar types. So let's set up a brand new query for that. Right here, we're going to set up a query for a grading application. We're going to call the operation grades, and we're going to set it up to return some array-based data. For an array type, we start off with square brackets, much like we would if we were creating an array in JavaScript itself. Now after this, we can also choose to put an exclamation mark on there. That says we are always going to get an array back, even if it's an empty one. If we left that off, we could indeed get null back as a valid value for grades. I'm going to leave the exclamation mark on. So if there are no grades, we'll just send back an empty array. If there are grades, we'll send back an array of numbers. The next thing we have to do is actually specify the type for all of those array elements. So is it an array of strings, an array of integers, booleans, IDs, what? In this case, we are going to use an array of integers, where each integer represents the percent you got on a given exam, where a 10% would be really bad and a 99% would be very good. So right here, if we want an array of ints, we have to specify that scalar type right here, int. Now, in the case of this internal type, we can also choose to put an exclamation mark on or leave it off. If we leave it off, it's nullable, meaning that I could have an array where one of the elements is null. If I add it on, it is non-nullable, meaning that if there is an item in the array, it is always going to be an integer. So with this example, we're saying we're always going to get an array back, and if there are items, they are always going to be ints. It would still be valid to get back an empty array via this type definition. So now that we have the actual operation defined in our type defs, let's go ahead and set up the grades resolver down below. I'm going to put that right here after add and before me, though the order is not important. Grades. I will set up all of the arguments necessary for grades, even if I'm not going to use them. It's a good idea to get into this habit for all of your resolver functions. So I have parent. Next up, I have args. Then I have the context. Then I have info. And all we're going to do is return an array of numbers. So we can pick some numbers. We'll say that you got a 99 on the first exam, then you got cocky and didn't study, and then you got an 80, and then we'll say you got a 93 on the final one. So here we are returning an array with 3 integers as our 3 elements. Now we can actually test out this new operation. I am going to save index.js and create a new query over in GraphQL Playground. I'll put this in a new tab just to clean up the output, and we will set up the operation, a query. We are querying for grades, and that is it. We can now fire off this operation, and what do we get back? We get back an array of all of our grades. So we have our grades property with our array of those 3 integers sitting right inside. Now in this example, you'll notice that we didn't provide anything after the field itself. I just specified grades. What I did not do is provide a selection set using the curly braces like this, where I specify what I want from each grade. This is not something we can do for an array of scalar types, like an array of integers, an array of floats, or an array of strings. Specifying a selection set like that is only something we do for an array of custom types. So for example, in the demo API, we explored that when we wanted to get a posts array back, I had to specify which fields I wanted for each individual post. So with an array of custom types, you have to specify that selection set. With an array of scalar types, you can't. Now in this case, we are sending arrays from the server to the client. Let's see how we could do things in the other direction. And to explore this, what we're going to do is set up add to take an array of floats as opposed to specifying just 2 arguments. So we'll let the user add up as many numbers as they like, as many as they actually provide in that array. To start, I'm going to delete all of the old arguments we had in place. So we'll remove A and we'll remove B. Now we have emptied out the parentheses and we can define the one argument that add is actually going to take. I'll call this something like numbers, and this is going to be an array of all of the numbers that you want to have added up. So right here, for the type definition, we will have something very similar to what we had right here, though instead of an array of our ints, it will be an array of floats. So I specify my array. I'll put the exclamation mark back there, meaning that you have to provide the numbers argument. Then inside of there, it's an array of floats, so float with an exclamation mark. And there we go. We are now always going to get an array, and when there is an item in the array, we know that item is indeed going to be a float. With this in place, with our type definition actually changed, we can go ahead and use this new array argument down below in the resolver for add. So we can start by removing all of the existing code, and now we can actually look at args.numbers to figure out how many numbers we need to add up. Let's start by checking if there are actually any numbers to add. So we know there's going to be an array, but it might be an empty array. So we can use an if statement. If we're going to check args.numbers, which we know is going to be an array, and we're just going to look at its length property. If the length is indeed equal to 0, what are we going to do? I'm just going to return 0. So we'll say that if you don't add up any numbers, you're going to get 0 back. The next thing we want to do down below is run some code for when the number's length is not 0. So when there are actually array items to add. And for this, we're going to use the very popular, very common array reduce method. If you've never used reduce before, it's a handy array method for reducing an array to a single value. In this case, we are trying to reduce an array of numbers to just a single number. You can always learn more about it by Googling MDN reduce. That'll bring you over to the Mozilla Developer Network page for the array reduce method. We're going to go ahead and actually implement this right here. And for our purposes, let's say we have some sample data being passed in. Let's just say it's 1, 5, 10, and 2. So down below, what are we going to do? I am going to return a value. That value is going to be the value that comes back from calling args.numbers.reduce. So here we are just calling reduce on our array, sending the return value back as the return value for add. Now we have to provide a function to reduce, so we provide a single callback function right here, like we do for most of our array methods, such as for each, map, and others. And this gets called with 2 arguments. The first argument is called the accumulator, and the second argument is called current value. Now, if you have an array of a single item, that single item value is always going to be the return value for reduce. This callback function will actually never fire. It is only when we have at least 2 array items that this callback function comes into place. So the first time this function runs, it is going to have the accumulator value equal to the first item 1, and the current value will equal to the second item 5 in this case, and it's our job to reduce that to a single value by returning something. So in this case, we're trying to add numbers up, so I can return the accumulator with the value 1 plus the current value with the value 5, resulting in a return value of 6. Now, the next time this function runs, 6 is the accumulator, and we move on to the next item to get the new current value. So we have 6 as accumulator, and we would have 10 as current value. We add both of those up, and what do we get back? 16. So then the callback function runs another time with 16 as the accumulator and 2 as current value. We run that, and what do we get back? We get back 18, and that's exactly what we would get if we added all of these numbers up. Let's go ahead and actually test our work. So I'm going to save index.js, and we are going to call add over here. I'm going to remove my grades query. I will use the add query operation, and right away we're already getting an error saying we have not provided the argument that it expects, but it's referring to A and B. Let's refresh the schema to get the same error, but with the numbers argument. Now we can actually call that, passing in the correct arguments. So numbers is the only one we have. It is an array of numbers, so we will set up an array of numbers. I'm going to use the same numbers from the file 1, 5, 10, and 2. I go ahead and run that operation, and what do I get back? I get back 18. So in this example, we're actually sending an array from the client to the server, and now we've seen arrays going in both directions. So we can send array data either way, depending on the needs of our application. Now, in almost all cases, arrays are going to be the value that comes back from the server. It's not that common to be sending arrays from the client to the server, though it is indeed possible and sometimes necessary. That's actually where I'd like to stop for this one. Now, we haven't talked about arrays of custom types. That's because I'm breaking up our discussion of arrays into 2 videos, preventing this one from getting too long. So in this one, we explored arrays of our scalar types. In the next one, we'll explore arrays of custom types, and there'll be a challenge requiring you to use everything you've learned about arrays so far. I'm excited to get to that, so let's go ahead and jump right in. That's it for this 2-hour preview of the modern GraphQL Bootcamp. I hope you've enjoyed what you've seen so far. Once again, there is a link in the description down below to the course landing page. There you can check out the entire course curriculum and explore all of the fun and interesting projects we'll be building along the way. I'm Andrew Mead, and I hope to see you in the full course sometime soon.